Hi and welcome to this video, which is Pro Teaches Noob Testing. In this video, we're going to cover testing from a beginner's point of view, and we're going to cover a few things about testing, but primarily it's going to be unit testing. Now, in this session, we're going to have a lot of practical examples. It's going to be primarily practical examples, in fact, but then we will have a theory section at the end where, because in the practical examples, we'll be talking about this is what you should do here, this is what you can do there, pros and cons. So that's great, but yeah, we need to summarize it properly in the end. So we'll start with a bit of introduction, a lot of practical about testing, primarily unit testing, and then recapping the theory at the end. So I'm here with Nick. He's my brother. He's a JavaScript developer. He's a pretty good JavaScript developer, but he doesn't have as much experience in testing throughout his career as I do. So today he will act as the noob and I will act as the pro. So Nick, before we start, why don't you introduce yourself quickly?
Yeah, hello, my name is Nick. I've been developing for a little bit of time now, but in terms of testing, Spiros has been an advocate for testing for quite some time, and he has studied it extensively and used it in his professional career for a few years now. So I'm really excited to learn what he has to teach me, and also then hopefully have all of you gain some of this knowledge as well. So
great. All right. Cool. So I think let's just get straight into the introductory bit. So we're talking about testing in general. So first of all, why do we even test? And Nick, remember, you're the noob here. So pretend you're more of a beginner than you are, right? Feel free to answer.
Okay, well, even as a beginner, I would assume that we test to make sure that our code works. What I wouldn't know is how do we go about those tests? How do we build them and how do we implement them? And also what different types of tests are there? So if you could tell us a little bit about that, that would be great.
Yeah, so let's start one at a time then. We'll start simple. Why do we even test? So we test basically because we make mistakes. Okay, so if we didn't make mistakes in our code, then any time we spend writing tests would just be a waste of time because they would be useless and unnecessary. So we make mistakes. That's the fundamental reason why we test. The other thing is we do test, but as a project grows, you're working in a large company, you have an enterprise project, you can't test everything. When the project is small, no problem. You spend 10 minutes in the browser, yeah, it's working, great. When the application is large, obviously, you just can't do that. It's impossible. So we must write automated tests to make sure that our code works. So that's that question out of the way. And second, what kind of tests do we write, as you kind of alluded to? Yeah. So you name it. We have a ton of different kinds of tests that we can write. For today, we're going to focus primarily on unit testing, which are some of the most common tests that developers write. And those tests are, the common ones are unit testing, integration testing, and end-to-end testing. You also have, again, you name it, performance testing, security testing, accessibility, internationalization, stress testing, I can name like 20 more, But we're going to focus on unit testing today. And that's for a few reasons. So first of all, jobs require them. So if you're a beginner at testing, you need to know these for your jobs, most likely at least. Secondly, they're important. So it's not like you're skipping the important ones. No, unit testing is very important. Thirdly, they're easy to start with. So again, great for you to learn testing with. And fourth, all the concepts that you're going to learn about unit testing transfer to basically anything else. So I just think it's a great starting point overall for you and any beginner out there. Okay?
Yeah.
All right. Any questions so far?
No, that sounds really good. I think maybe people may not understand specifically what unit testing is, but we're going to get into it. And if I may butt in here, I presume by unit testing, you mean testing individual modules or even individual functions and lines of code to make sure that they produce the results you're expecting.
Yeah, great point. Else. Yeah, that's right. So unit testing means something like a function. You're literally testing that your function works, or something like a class, or as you said, something like a module. Yeah, thanks for bringing that up. End-to-end testing would be something like you go to the browser and you check that your application works as though you were an end user. And integration testing is something in between end-to-end and unit testing. So yeah, today we're going to start simple with functions and classes.
All right. Sounds good.
All right, great. Cool. So another quick thing for you to be aware of is that a lot of developers have objections to unit testing. They think, or they might think at least, that unit testing isn't good. It has a lot of downsides and not a lot of upsides. I don't want to spend too long into this at this point. I just want to reassure you that unit testing is good, and the downsides, we can mitigate them a lot by learning how to test well and by learning how to write better code. But we'll tackle this point more in the theory section at the end. Okay?
Okay. Yeah.
Yeah.
That's fine.
All right, great. So with that, I think we're ready to start the practical examples. All right?
Very good.
So just for any viewers out there, the practical examples that we have are using JavaScript, and they're using a test framework called Jest. We're not going to go over how to set this up because the concepts here are universal. You can use them for any language. It doesn't matter if you're using C# or Python or any other language. You know, as long as you can see a function and you can translate it into your own language, which you'll be able to do, that's not a problem. So we're not going to cover how to set up a test framework because it would be different for every one of the viewers, for every one of you. So instead, what you can do, if you spend a few hours in your own target language watching a tutorial or something, you should be able to do that yourself. In the meantime, everything we do today, you should be able to understand quite easily. It's just a generic test framework, just like one you'll have in your own language. Okay, so with that, would you like to start, Nick?
Yeah. Okay. So
here Nick is sharing his screen. And for the first few minutes, we'll just spend a minute or two talking about how the test framework works. If you're using your own test framework, no worries. Feel free to skip a few minutes until we get to the first example. So here, this is just to show the syntax. So we have a very simple function named add, as you can see there, and all it does, it adds two numbers. So to showcase the test framework, Nick, would you like to go to the test file for this function? Okay, yeah, so this is the test file, and we're doing something very simple. Firstly, we're importing the add function from our source code. This is something you're probably going to have to do for every test framework. You need to give access to the test framework to your source code. So that's what we're doing in the import statement here. And then with this particular framework, this is the syntax. We write a function, well, we call a function called test, and we pass in a message that if our test fails, the framework is going to display this message and tell us, hey, your test failed. This is the test that failed. And then we pass in a callback, a function, where we have our test. So the test framework executes that. So just as an example, Nick, would you mind changing the to be line 5 from 2 to 3? Let's make the test fail.
Yeah.
Okay, click on save. And then on the bottom right, you'll see the tests are executing. It's going to execute all of them because it's a limitation of the code sandbox thing that we're using now. So it will take a few seconds. Okay, and we see that one test failed. And at the top there, it has the message add 1 should return 2. In red, it shows it failed. And it shows what failed. So it says it expected 3 because that's what we've put on line 5, but instead it's received 2. So this is very generic test framework stuff. They all do useful things like that to help you out with your tests. That's it, very simple. So next, Nick, why don't we change it back to 2 and then move on to the actual first example?
All right, sounds good. I saved. Did you want to run the tests to see the result, or should we go straight to
It's fine, file? Like they were working before.
All right.
Yeah, so let's go.
Here we are.
So let's close this file and let's go to the second folder where it's named 1 pure units.
Yeah. And I'm assuming we're going to add.
Yeah, so let's start very simple. We're going to start with a function called add. And you might be thinking, like, I'm writing a lot more complicated source code than this. I don't need that. Don't worry, we'll move up there as well. But we'll start simple so we can get used to testing first. Yeah, so open that. This is the function. The function like is already complete. So let's open the test file and we can start writing some tests. And by the way, for the viewers out there, we're testing here a pure function. So that's a function that takes in some arguments and returns something, but it doesn't access anything outside of the local scope. It doesn't access any globals like the DOM or the database or anything. It just does a calculation. That's a pure function. And if you're using an object-oriented programming language, this is equivalent to a static method. So if you don't have standalone functions like this, we're testing static methods for your programming language. Okay, so with that, so we have an empty test file and we want to test add. So Nick, what kind of tests do you think we should write before you start writing any to test that? What should we do? What are your thoughts?
So we need to test that add returns the expected result. So the expected result in this case would be whatever two arguments we pass in, the addition of those, the sum of those, has to be returned correctly. We can also implement tests later on that test for type coercion as well. So if you pass in something that isn't a number, JavaScript has quite complicated type coercion, as you know. So is it going to coerce it into a number and return an unexpected result, or is it going to throw a type error? But as far as I'm aware, we test one single thing at a time. So the first test that we would create would be the sum of two numbers. Does it return it correctly or not?
Okay, yeah, that sounds pretty good. So let's start simple. For these basic examples, let's ignore type coercion. Let's do that later. So to kind of summarize what you said, we can't write infinite tests. So we just write a couple until we're confident that our function works. So in this case, we might do some simple cases like 1 + 1 or 2 + 1 or something like that. And normally we would do some edge cases as well. So like, but I don't think we really have edge cases here, except maybe what if the function is so large that JavaScript can't handle it. I think for these simple examples, let's ignore it. Let's just write some simple tests. Is that all right?
Okay. Yeah.
Okay, cool.
Yeah. So I'll start with the message. So we'll write what the function call is going to be. So add 1, 1, let's say. Should return 2.
Nice.
And then inside our callback, we get the result. We get the result here. So we call add 1 and 1. And then, do you want to run us through what the syntax was?
Yeah. So with our particular test framework, we write expect, the word expect, open parenthesis, result. Yep. And then dot to be, and then like parenthesis 2. That's right. Yeah.
Very good. And then if I save, we get to see what the terminal tells us, whether the test passes or fails.
Yeah.
Now, we should mention that if it fails, this is the message that will be logged.
That's right.
So it is important to make sure you add or you write a message, a note that is descriptive and lets you know what actually failed.
Yeah, that's right.
Is that correct? Yeah.
That's right. Yeah, so in this case, we have a simple function. So I'm just thinking, let's keep moving. Let's just write 1 or 2 more tests until you give us confidence, and let's move on. So let's just do 1 or 2 quickly. And you don't have to do this, but what I normally do, by the way, is I copy the previous test, paste it, and
I
then,
know. Yeah. But just to go through it again, so we'll do maybe 3 and something like a large number. So actually what I'm going to do is 97, because then we know that the result should be 13,000. Should return 13,000. Is that okay?
Yeah.
And then as a second argument, we pass in. Now, can this function be an arrow function as well?
It can, but let's ignore that because different languages may have different syntax.
That's fine. Add equals 3 and 1, 2, 9, 9, 7. Okay, that's our
cool.
Second test.
And we need to close the function call with a parenthesis there.
Absolutely.
Yeah, so that's our second test. Yeah, so at this point, if you wanted to, you could write one more. You might want to try some negative numbers, but really, testing is about writing a few tests to gain a lot of confidence. So as long as you were happy, okay, my function is working correctly, then it's fine. You can move on.
Let's write one more with a negative number. So that should be 12,994.
Yeah.
Oh. There we go. And now we can run the tests.
Mm-hmm.
Now, while the tests are running, could you explain to me a little bit what this testing framework is? And maybe what we could do is add a few links on the description of the video for some popular testing frameworks that people can look up for different languages. Because I don't know if many people are going to know what different frameworks are available, and if there are many, which ones to choose from.
Yeah, so Zest is a really good testing framework for JavaScript. It's my personal favorite. Mm-hmm. I don't want to claim that it's the best or anything. I'm just saying that I really like it because there are differences between all of them. Unfortunately, I don't really know of the testing frameworks for different languages. But honestly, whatever is popular in your language, you can't go wrong with. And let's be perfectly honest, a testing framework is the last thing you need to worry about. You need to know how to test first, and then any testing framework you use, it doesn't matter. It's a small detail. So if you really don't know where to start with, I would find a popular one for your programming language and just start with that, and you'll be good to go, I think.
All right, that sounds great. And also, another question, if I may. This test function is part of the framework. So you didn't personally have to create the test function, and now we're using the utility. It's actually part of the framework.
Yeah, that's right.
All right, fantastic. Okay, very good. And we can see that 14 tests passed out of 14 total. Now, can you explain what this is? 1 skipped, 49 passed.
You can ignore that. It's because in this project I've included the solutions, so it's running a lot more tests.
It's running all of them. Okay, I understand.
Yeah, and I've skipped one because one of them would fail, and I've put this in the bad examples of what you don't want to do. So
all right,
yeah, we can ignore that one.
Fantastic. Okay, so what would be the next steps here?
Okay, so now we have a couple of tests that give us sufficient confidence that our function is working correctly. Now, if you wanted some more, no problem, just add some more. Like, for example, we haven't tested 2 negative numbers. If you want to do that, it's not a problem. But I think for right now, this is good enough. I'm happy the function's working. So let's move on to just a slightly more complicated example. Still simple, but we have the next. So that's the next complicated example. Let's move on to multiply first.
No problem. Here we are. So this multiplies 2 numbers. This is the utility function. Again, this is a pure function. It does not actually change the state of any program, and it returns a new variable based or a new value based on the parameters that it contains and the arguments that it receives. Now, you don't have a testing file here. You've only got the solution. So is this sort of telling us that we need to create one ourselves from scratch?
Why not? Why not just do it? So how Zest works, what you do with Zest is you create a file named the file name .test.js.
All right.
Yeah.
And we need to import multiply from... All right, so here is the... By the way, for those of you who don't know, we're using ES6 module syntax. So if you're not sure what we're doing with export and import, just look up ES6 modules. It's just a way to get different files to interact with each other. So for example, on this file here, we have access. We can call the function inside this file. If we didn't have this export and import utility, we wouldn't be able to do that right now with the way that we're utilizing these files.
Yeah.
Oh, ES6 modules. Okay. All right. So we're going to write the test again. Shall I begin? Or do you want to
go ahead?
All right. So test. First argument is a string.
First of all, tell us what kind of tests you want to write for this function.
All right. So if we're going with basic tests, you simply want to test a couple of different cases of multiplication. One of one of positive numbers. So, 2 times 2, 2 times 10, whatever it is. One potentially of negative numbers to make sure that you're also getting the correct result using negative numbers. And one possibly of very, very large numbers to make sure that the function still runs and there isn't something that's preventing it from running.
Okay, so to summarize, we have a few common use cases. So for example, you might do multiply 1 and 2, multiply 3 and 6 and whatever. And we also want to test a few edge cases, which you kind of covered. So you said some really large numbers. That might be something that might be a potential edge case, something that wouldn't work like normal. And also in this case with multiplication, we might also want to try one test using 0. So again, that might be something that doesn't work as normal, depending on how you think about it. And you also mentioned negative numbers. So I think you covered pretty much everything. I would just say, let's do one with 0 as well, just in case.
So let's start simple because my arithmetic skill is not the absolute best.
Okay.
Multiply 2, 2. These are the 2 arguments I'm passing in. Should return 4. So 2 times 2 equals 4. And then we pass in a callback where we get the result of multiply with the same arguments as the string that we passed in as the first argument. And remind me what the syntax is here.
Yeah, it's expect result
That's it.
to be
dot to be 4.
Yeah.
And let's write another one. If you don't mind, I will copy and
That's
paste
fine,
over here. So we'll do 0, 2 should equal 0. And then, one sec, we'll write one more with negative numbers. So multiply, minus 2 times 2. What would that return?
Minus 4.
There we go. So we've got our 3 tests. When we run them, we should expect that they all return true. If something returns false and it gives us this error message, then we need to go and look at the function and try to troubleshoot what is wrong with it.
And while we're at it, why don't we also try some quite large numbers, just as another edge case?
Absolutely.
So just to mention something here, we don't need to literally test the limit of integers, or like the maximum safe integer in JavaScript. Let's not go that far. Yeah, something like what you said there is good enough. Let's not
2,000 times 45,000.
Yeah, and actually,
which should equal
no idea what that equals.
90,000.
Did you use a calculator? Because that's what I'm doing.
Use a calculator.
Okay, that's fine. Yeah. Okay, cool. So, right, let's actually write the test.
Yeah, what should it return? Did you look it up?
90,000, you said, right?
No, it's not 90,000.
I didn't look it up. Just write 90,000 and add 3 zeros. That ought to do it.
Are you sure?
Is that the correct number? Just write it and see if it fails. It's fine.
Okay. If it fails, we also know we're on the right track because we have probably given it the incorrect.
Yeah. It's fine. Anyway.
There we go.
Cool. And that's a story about it. Actually, we haven't tested decimals, so we don't have to do it now, but you get the idea. We would add another test to make sure that decimals work correctly.
Yeah.
Or maybe because it's a common case, maybe we would change one of our earlier tests so we didn't have too many unnecessary tests. But as long as you get the idea, I'm happy. Let's see what the tests are doing, and then let's move on to the next example, I think.
Okay, so as you can see, the tests are finished and they have all passed. And I'm going to scroll up so you can see what the tests that we wrote are.
Yeah. So we have 2 and 2, which is a common case. We have something testing 0, which is an edge case. -2 and 2, which again is another common case. And large numbers, which is a little bit of an edge case. So I'm happy with that. Let's just move on to the next example.
All right, very good. Are we going on to CalculateDamage now?
Yeah. So this will be the last one of our pure functions. And this is to show you that a pure function doesn't have to be simple. It can still be somewhat complicated. Not that this is super complicated, but I hope you can see the idea of how this would relate to your own code. So in this one, we have a few more edge cases we need to worry about, basically.
So we've got function CalculateDamage with 2 parameters. Attackers attack stat and defenders defense stat. I like this. If attackers attack stat minus defenders defense stack is above 0, return attackers attack stat minus defenders defense stack. Otherwise, return 0.
So essentially, CalculateDamage returns a minimum of 0. You can't do negative damage.
Yeah.
And otherwise, the damage you do is the attack minus the defense. Okay? So that's all this function does. So yeah, let's move on to testing it.
Okay. So I'll create a new file. We'll call it calculateDamage.test.js, correct?
Yeah, that's right.
Mm-hmm. And then we'll do import.
Oh, small typo there. You mean /. I do that all the time.
No worries. And we run our first test. Now, let's talk for a second about what kind of tests we need to run here. Again, it's mathematically based. So you just need to make sure that you know what the result of the function should be. But there's a couple different possibilities here, because say we pass in 1,000 and 1,500. So attack damage minus defense, that will result in minus 500, correct? Because we've got 1,000 minus 1,500, but it's not going to return minus 500. It's going to return 0.
Yeah.
If you look at the function here, if the first number minus the second number is bigger than 0, then return whatever that sums up to be. If it's not, if it's smaller than 0, simply return 0. So you've got to remember what your function actually does, and make sure that when you write the tests, you write the tests correctly. Because I'm assuming there's also a case where you might write some tests incorrectly and they might be failing, not because the tests failed, but because you wrote them incorrectly.
Yeah, so how you want to do it is you don't want to read your function and see what it does. That's what we're doing here, because we assume the function works correctly. Instead, you think, what's my function supposed to do? And then you write tests for that. That way, if your function is wrong, your tests will fail and you can fix it. So that's how you go. What is it supposed to do? And you write tests. In this case, this is like a test session. Pretend the function is correct and you've seen what it's supposed to do. Now write tests for it, you know?
Okay,
But
so
yeah,
for example, we
point.
can say 1,000 calculate damage 1000, or let's keep it simple, 1 and 5 should return 0. Ooh. Don't close the string too early. Coding 101. Const result equals calculate damage 1 and 5. What was it again?
Right. It's expect result to be.
That's it.
Yeah.
I remember the rest of it. It's just that first word.
Yeah, that's fine.
To be 0. So that is our first test.
Mm-hmm.
Let's write another one where we have this, and the result should be 4.
Yep.
And then in this situation, you'd still want to test for, let's say, negative numbers to make sure that they still return 0 and nothing unexpected happens. Correct?
So I'm glad you made this point, but let me take over and talk about it for a minute, okay? Mm-hmm. We're completely ignoring that for this example. Forget negative numbers, because this is just an example for testing. In a real code base, you would have to think hard about what are you doing with negative numbers. Can attack be negative? Can defense be negative? What happens if they are? Does it just, if you have negative defense, does it add to the damage? So there are a lot of considerations that are about the game design in this case. So we're just ignoring all of that. Pretend the function works correctly. Ignore negative numbers. Let's keep it simple. Okay?
Okay.
Yeah. But it's a great thing to think about because you're thinking of edge cases. You must think of edge cases like this. So, yeah, very good.
I am your brother.
Yeah.
Would there be, of course we can test for very large numbers too. Is that something you would always also, 1 second. Right, I copied it to create another one. So for the last one, let's maybe test for a couple of large numbers. So 5,000 and 1,000 should return 4,000. And regarding what you mentioned, aside from these tests then, would there be any other test that you would run in a real life scenario for this specific pure function?
So if the function was literally like this, so we pretend it's correct. So right now, how it handles negative numbers is if you have negative defense, it adds to the damage. If you have negative attack, you get a negative damage. We ignore this, but say that was how it was intended to be. Our game designer told us this is what I want. We would add tests for that as well. Because what you want to do, and you've done fairly well here, you want to test a couple of common use cases. So I think we have 2 of those tests. You have 5 and 1 and 5,000 and 1,000. I'm fairly confident with those. I'm happy. You've also tested the only edge case I can see, which is the 0. And of course, if we were handling negative numbers, those would be extra common cases that we might want to test because they're not exactly the same as the common cases we've tested now. At least that's how I would see it. So overall, I think you've done quite well here.
Okay, very good. Mm-hmm. So I'll run the tests, and we are presuming that all of them are going to pass.
Yeah. Because again, this isn't normally how you would do it. You might write tests at the same time, but here we're only showcasing the testing. We're pretending the functions are correct already.
All right, very good. And yes, same result as before. They have all passed and one has been skipped, which is something you've done yourself.
That's great. Cool. So next, we move on to more complicated stuff. We've done pure functions. Now, we'll move on to some side effects. And the key point I want to...
Impure functions.
Yes. And the key point I want you to take from this is that how easy was it to test these pure functions?
Yeah, this was very easy. It seems to me like with pure functions, such as these at least, you wouldn't really even need a testing framework. You could console log the result and check that the result is correct manually with a calculator. Not that that's the ideal way to do it, but this was a very, very simple test.
Yeah, pretty much.
So, you should still have the mindset of testing with a framework going through the correct process because it's the correct mindset to have. But you could technically test these functions without Jest or any other testing framework. With side effect functions, I presume it gets a little bit more complicated because now it changes the state of your program.
Yeah. So we'll get into it, but yeah.
Okay, yeah. Let me know which file to open first, and then I'll let you give an introduction.
Okay, so before we actually move on, the key point I want you to realize here that you'll see in the following examples with side effects and IO and bad test is that testing these pure functions or static methods, depending on your language, is super easy. There's nothing to it. It's so easy, you know? You just call it with some inputs, you get a result. Unit testing, some people think unit testing is hard and that it's a waste of time. And the answer is, I'm alluding to what we'll talk about in more detail later, it can be, it depends, because if you write pure functions like this, unit testing is super easy. So one of the key points that we'll see in more detail later is that good tests and maintainable tests depend on good code. If you write good code, if you manage to write pure functions wherever you can, and not the examples we see later, testing is super simple. If you write code that would be considered bad, that is full of side effects, that is full of IO effects and functionality combined, then testing becomes pretty much impossible. So bear this in mind. It's one of the points. We want as many pure functions as possible in general. And this is part of clean code. This is not part of testing, right? Because good tests depend on clean code. Okay, yeah, that's it. That's enough of a rant for now. Why don't we move on to the next example? Let's tackle the stack example.
All right. So we're now into impure functions that actually have side effects. The stack class, and it's a very simple class. It's basically a stack. It allows you to add elements to the very top of an array and pull elements from the very top of an array. And it allows you to get the size, so how many elements are there, the length of the array, as well as whether it's empty or not. Now, Spiros, you mentioned something about potentially adding error handlers over here for cases where there may be errors, like trying to pop when the array is empty, for example.
Yeah, that's right. So in a real implementation, we might have on the pop something like if stack is empty, throw an error. Okay,
yeah,
which is fine. It doesn't change the code as much. I think let's go over this in a minute. Let's actually start writing some tests for this first, and then we can expand with that later. Yeah?
All right, very good. So here's our test file.
Okay, so before we start, this is a different beast. So let me give you some pointers before we start. So how do we test something like this? Okay, so here's the thing. If we were using a different programming language, right? Other programming languages have private methods and private properties. Like, for example, for all intents and purposes here in our stack, the state of our stack is private. No one should be able to access that directly. Now with JavaScript, private properties are coming. They're not quite here yet, as far as I know. But for all intents and purposes, pretend they are private. We are not touching the private state of the stack. So how do we test something like this? How do we test that we've pushed something and that it's worked? So thankfully, it's not so bad yet. I mean, with certain code is a lot more difficult to test. What we do here is basically we use the public API the public functionality of our class. So with stack, those are the methods pop, push, size, and what is it? Is empty. Okay, so we use that. So with our tests, if we want to test that push is working, we have to do something like, push to the stack and then check if it's empty. More likely, pop from the stack, this is in the same test, and check that we got back the item we expected.
Okay.
That's how we do it. And this is very important for the viewers watching this. You should not test private state. Just because JavaScript allows you to, you shouldn't get in there and get the array and test that the item has been pushed. Okay, yeah. You check through public functionality. And we'll go over this more later. But yeah, let's just go on with that for now.
So first, let me import it. Import stack from and then
you have a little.
Yeah. Okay, so is it okay if I go ahead and try to code the first test myself? I have an idea of how it could be done based on what you said.
Well, why don't you describe it a little bit first?
Yeah. So my opinion would be that we would test, let's say, pushing in a value, popping a value, and then getting the result. So testing to see whether the array is empty. Another test would be pushing in maybe 2 values and testing to see whether the array has 2 values. Another test would be pushing in a value or 2, getting the top value, so popping the value, and checking whether that popped value is the last thing that we pushed in. And then a final test may be like in the case of trying to pop when the array is empty, testing that we get an error, or in this case, false, because it's simply returning true or false.
Okay, yeah, so all the tests you said sound pretty good. So firstly, this is just an organization thing for me, but what I like to do is I like to categorize my tests by method. So for example, from the stack, first I want to test the push function. So like, actually, yeah, the test framework gives you a nice way to do this. Let's do this now. Let's add some categorization. So go above line 3.
Yeah.
New line. Type describe.
Like
as
a
an
comment
actual
or
function. Yeah. It's a cool thing that Jest gives us. Describe open function call. And then type a string push. And actually in real code here, we would want something specifying stack, but let's just ignore that for now. Let's do that later. So yeah, you're doing push and then comma and the callback. So a new function, open that, and now put all your tests in there. So take the test and put it on line 4.
Okay.
So I like to do this, and I like to be okay. I'm going to write tests for the push method and so on. So let's focus. How are we going to test push? In this case is what we want.
So would we do something along the lines of stack.push, let's say that just the value 4 as a string to keep it simple, or even just the number, .push 4 should return an array. It doesn't return though, does it? .push 4 let me see what implementations you used. Okay, maybe we could do .push4.pop should return 4. Could we do something along those lines, for example?
Yeah, something like that.
As the first one, for example, then the second one could be .push and then .size returns length of 1.
Let's just go with this, okay? Let's just say pushing, I don't know, like one item should add it to the stack. Let's just go with that because I can't think of anything better.
Okay. Stack.push.
Just ignore that. Let's write proper English this time because we're not using pure functions anymore.
All right.
So yeah, method should add push should add item to the stack. Let's just go with that.
No worries.
Close the string as well. There you go. Okay, great.
I like to be consistent with my strings. Go ahead.
Yeah, so I'll walk you through the first one if that's all right. So for this test, we need to, first of all, initialize the stack. Okay, so we've got something like const stack equals new stack or something.
Yep.
You know?
That's fine.
Yep. So let's add an item. So type stack.push. And then, yeah, 4
We'll
is
add the
fine.
number 4.
That's right. And then how do we check that it's there? So what I would do is I would pop.
You would pop?
Yes, to check that the item is really there.
That's fine. I believe that's the first example I gave. So we can do const result equals stack.pop.
Yeah.
And then expect result.to-be 4.
Yeah, that sounds good.
Fantastic. And that is our first test. So I'm assuming we can write a second test inside describe push.
Yeah.
What does describe actually do? Just so we have a...
Yeah, so it's just good organization for your test output. So you know where all your tests run on the bottom right?
Yeah.
It's just a namespace, right? So it says push test thingy. So you don't have to repeat it on every single test.
Okay, so it just lets you know on the terminal that these tests are under the push description, let's say.
Yeah, pretty much.
So those are all testing the push functionality, the push method. That's fine. Okay, so on this second test, could we push 2 items? The second one can be a string, hello, and then the pop should return hello. Would that be an acceptable test?
Yeah, that's what I would do as well. And in fact, we have to change the test name as well to signify that. But yes, I think that's a good second test.
Right. What do you mean by we have to change the test name?
Right.
Push should add. Right. You mean this?
Pushing twice should add both items to the stack or something. You know what I mean?
Push twice should add. That's fine.
Both items to the stack in the correct order, or like.
And pop, could we say, so it doesn't matter if the string's too big. So if I said pop should return the latest item pushed.
I wouldn't have it too big,
okay?
Yeah. It does matter if it is a bit big. I would just leave it with the pushing thing, I think. We'll have to think about it actually, because we found out later when I was doing this in the solutions, push and pop are so related that actually I ended up calling my describe push and pop. But you haven't seen that yet. That's something you would refactor into. You wouldn't know this up front.
Okay.
Does that make sense? So yeah, let's focus on push for now. And you want to specify the order as well.
In order of
I would just say in order,
execution. Yeah.
Whatever specifies it, yeah. So you get the idea.
Yeah.
Cool.
That's fine. All right, so that's our second test. Now, in terms of...
You also want to ensure that 4 is there. So I think I would add another pop in there, you know?
But can we do expect 2 results? How would we...
You would just do it twice.
The syntax for that? So you can write... You mean another test, not within this specific test?
No. So on line 15, you have your popping. On line 16, you're testing, and then do the same again. Or you can do that. Yeah, that same thing. So we can make sure they really are both in there correctly.
That's fine. And inside expect, can we add another argument, result 2?
No, it would be a new statement. Okay. Yeah.
Right. Okay. So this doesn't terminate the function execution. You can add another one there, correct?
Yeah.
That's fine.
Okay. So
very good.
What else would you like to do, if anything?
I mean, there's other methods to test, at least from the public API point of view. So we have the checking the length of the array to test. We also have whether the array is empty to test. Those don't directly affect whether elements are pushed in or pulled out, but they do affect data that someone might need to read, basically. But you wouldn't add those to the push described, correct?
Yeah. And also, before we move on, I personally would like to add another test for push, which would be... Oh, what's that?
We got an error here. So
it's because we changed the getter from the stack. Let's change it back to what it was, because remember, I have tests for it as well.
You have tests, right?
Yeah.
So just so people understand, this wasn't a getter function before. It was just a normal method call. Usually, when you want to pull just a value of something, so for example, in this case, we're getting the length of a technically hidden property within this class, you would just use a getter method, because you don't have to call it as a class, you can call it as a regular property. If you want to know more about this, there's plenty of information on getters and setters online, but yeah, we'll change it back now.
Yeah.
Because Spiros has written his own tests in the solution file.
Yeah. Not break everything. That's fine.
Yeah.
Okay, cool. So a last test I would like to add for push is, what if we push something and then pop it, and then push another thing and then pop it? Does that work? So basically, those three tests, in my opinion, will be the common use cases that we would expect to use a stack for. And after that, I would personally be satisfied.
Right.
You know?
So could we do like push 2, pop 1, then push another, do like push. Can we do other values as well? Or does it, I guess it doesn't really matter in this case, does it? So do 40. And then can we still log both of these? So can we say result should equal hello, but result 2 in this case should equal 40?
So, I mean, personally, I would just have them one after the other. So I would have on line 26, I would have the expect statement, and then I would have another go, so to speak.
Yeah, that makes sense.
You know? But you can organize them however you want. That's just my preferred way. And then I would have a new line after, something like that. Yeah.
That's totally fine. Right. So we're doing
and
push
actually,
times 2. Yeah.
Let's push once. So let's push only the number 4, and then check for 4, and then push 40, and then check for 40. You know?
That's fine. I mean, the reason why I wouldn't want to do that is because it doesn't guarantee that pop... Listen, we know the implementation of pop. We know it will always pull the final item in the array. But if you don't know that, it doesn't guarantee that pop is pulling the last item in the array, because you're only checking whether it's pulling the only item in the array. So you could be using unshift, for example, and you might be thinking it's pulling the last item. You might have incorrect information, but it's actually not. It's pulling the first item. You don't know this because you've only pushed in once. So I'd prefer to keep it as 2 pushes. Check this pulls hello, and this as a single push, and check it pulls 40. That's
fine. I wouldn't do it like that for a few reasons. I would like every test to be testing one thing. Well, not just me. That's what's nice to do. And like what you're saying is totally fine. Don't get me wrong. I'm just nitpicking here.
Okay.
Because that's what I do, I guess. Well, not really, but just in this case. And also the previous tests that it pulls the latest item in the correct order. So I have that confidence from that one. But yeah, it doesn't matter.
That's fine. Yeah. Okay, so to keep it clean then, because we do want to advocate for clean code, we can do it like this.
And also, again, we have to actually rename the test so that it writes the correct thing there.
So, yeah. So in this case, naming sometimes can be a little bit difficult, right? Because you don't want to keep... If you made it a long name, you could describe what it does, but you want to avoid doing that. So push should add item to the stack in order of execution. Would it be bad to mention pop here because we are using pop twice?
I think I would just say, like to keep it a bit concise, and I've had more time to think about this than you, so I'm sitting a bit here. Maybe something like pushing then popping should add and remove the item correctly or something, you know?
Something
From
like
the
that?
stack.
From the stack, yeah.
Yeah. Naming is
It could be
hard.
a set, it could be something else. Yeah,
Yeah.
that's fine.
So to summarize,
Push then pop.
Yeah. So to summarize, I think for the push function, the tests we have give me confidence that it works correctly. If we needed more confidence, we could add more tests, but there is a balance. You know, you balance confidence versus, well, you don't write a million tests, you know?
Yeah.
Yeah.
That's fine. So we do another describe. And we simply pass in just a callback, yeah? Or we do, right, a string to explain what method we're testing. So shall we test the length method? What have you named it? Let's test is empty.
Yeah, let's do it.
So is empty. And then we write the first test. The string should be push, then pop, should result in empty stack.
Okay, so sorry, let me pause you here. Sorry to be abruptly interrupting you there, but I would start with something more simple. I would say something like is empty should return true when array is initialized. Like straight after you initialize the array, it should be empty, you know? So in general, you don't have to do this. Anyone can do what they want with testing. But yeah, I like to start simple and build up, you know?
That's fine. And we're using British spelling here, hence the S and not the Z.
That's fine.
Just for everyone else watching.
We'll allow it. It's fine.
So we get a new stack and we can do const result equals stack dot is empty. And then we do expect result, not with capital. Dot to be true.
Yes.
Fantastic. So that's one test. We can write another one below. Could we write what I said before in this case? Push then pop should result in empty array. Or do you want to do push, like when you've pushed an element, it should result in is empty is false, basically, however we word that.
Yeah, so I would actually do 3 tests in total, with what you suggested being the most complicated test. So I would do that at the end, push then pop, that is.
Okay.
So one more thing. Let's have a quick side note here on how to name tests a little bit. So in general, following the behavior-driven development language tends to be pretty good. Many developers seem to like it. And that's something like this. Something should do something when something. So for example, on line 36, we could name it is empty should return true, right? That's the do something part, when something, when stack is initialized.
Okay.
So let's also fix line 36 with a is empty. But yeah, you get the idea.
Yeah, so is empty should return true when stack is initialized, and maybe is empty should return false when stack has elements.
I would
say that.
I would say when item has been pushed onto the stack.
Okay, I was trying to keep it more concise, but yeah, I prefer that. Okay.
Mhm.
And then new stack, we call push with any element. It doesn't really matter. Result should equal false.
Yeah.
That's our second test. And then the third test should be potentially what I said, which is if you've pushed and if you've popped, that should equal true. And then we need to change the message.
Yeah.
IsEmpty should return true. When item has been pushed, then popped from stack.
That sounds good.
Can I
to
say
me.
in this case, when single item has been pushed, then popped from stack?
It's all subjective. But yeah, I think both of these versions are good. Yeah.
Fantastic.
Mm-hmm. And if we looked at the tests, we would see them pass.
Yes.
But yeah, they take a while to run. That's why we don't continually show them.
Yeah. But let's show them once and then we can maybe cut.
But yeah, and also, as I kind of alluded to before, you want the messages to be good. So right now, if you have 1,000 tests in your code base, and I've worked in code bases that have 1,000 tests,
Yeah.
seeing the message is empty. Oh, sorry, one more thing. Like on line 48 and 36 and so on, we're saying is empty, but we don't need to because the describe already has is empty. So I forgot about that. Does that make sense?
Does it really matter?
I would personally delete it to remove the redundancy, but you would see how it shows up in your test framework and how you like it. In this case, yeah, I would remove it. And also for the whole file, I would have a describe named stack. So that again, in the tests, we don't see is empty blah. We see in stack is empty does this. Because imagine, we have no idea what this function
So are
relates
you
to.
saying, just so that I understand correctly, you'd have an outer function call of describe.
Yes.
Inside that you have more nested function calls of describe for each method.
Yeah.
So you'd have describe with stack.
Yeah, with a capital
Or maybe
S to match
stack because it's a class. Yeah.
Yes.
Oh. And then in here you'd put all of this.
That's right, yeah. And that's just so your output in the console makes sense. So you see stack.
It makes sense. Yeah,
push.
absolutely.
Yeah, that's good. I'm glad.
Okay, very good.
Yeah.
Now, we would need to also test the method that I would have as a getter, which is getting the length of the array and making sure that's logged correctly.
Yes. Yeah.
In this situation, though, no, I guess you would need to test it because it should show the correct result if you've coded it correctly and it's actually getting the length of the array. But if you've done something weird and haven't coded it correctly, then you'll get an error. So that's fine.
Basically, you need to ask, from my tests, do I have enough confidence that all the public methods work correctly? You know?
Yeah, that's fine, man. No worries. So another describe with size. So we need to do size should return 0 when stack is initialized.
That sounds good to
And
me.
then we can do size here. Results should be 0.
Mm-hmm.
Size should return, let's say, 1 when single item has been pushed into stack.
Mm-hmm.
We push single item, we get the size should return 1. Size should return true, or let's say 10. Let's not do 10 now, but 3 when single item has been put, when actually, hold on. Let's do size should return 1 when 2 items have been pushed and 1 popped from stack.
Okay. That's reasonable.
Cool?
Yeah.
Yeah. And then we push 2. We pop once. Size should return 1.
That sounds good to me.
Fantastic.
Yeah. And we might just want to check, just as a sanity check, what about 2 items have been pushed? You don't have to. It all depends on how confident you feel. But I think I would like to do 0 items, 1 item, and 2 items myself. And as you did, you deleted an item. That sounds pretty good as well.
Very good. There we go.
Lovely.
Size should return 2 when 2 items have been pushed into stack.
That's great. Okay, and so we've now tested 3 of the public functionality, 3 out of 4. We still have pop to go. But as I said, I'm cheating a little bit here, but when I made my test for pop, I thought they're so similar to the push one, I just put them together. So
yeah,
you have the choice. You can do the same thing straight away, or you can make the pop ones. Because remember, at the end of the day, tests are code. So you refactor tests just like code. So I hope you get the idea. Yeah.
I do. Let me fix the indentation a little bit.
Okay.
That's fine. All right, actually, all it was that. When I copied some from above, I copied the closing parenthesis for the entire outer function.
Right, yeah.
That's why. Yeah, no worries though. Little things, but thankfully your code editors, if you've got any modern decent one, should let you know when you make little mistakes like that.
Yeah.
And if not, your terminal will let you know when you try to run something. Yeah. Okay. Shall we go to the next file?
Let's do pop, because we still haven't done that properly.
Okay, that's fine. So I will copy this just to keep it a bit simpler. In this case, we do pop. The first one, result should return. Let's do the string hello.
So with pop, again, I like
this is where, go ahead.
Sorry to interrupt you. I like to start simple and build up. So when stack is empty, I would expect pop, in our case, to return undefined. Or, and this is what we alluded to before, you might have some error handling. You would expect pop to throw an error, and you would test for that. The test framework allows you to test for that.
Pop should return undefined when stack is initialized. Let me write here another one that I thought of. So pop should, not that, pop should return the last item pushed to array.
So,
and here we can push an item and...
Again, let's start with 1 item. Yeah? And then, as you said, doing 2 items would be the next step. That makes sense. But yes, you're right, though.
This is still technically correct, even if we only push 1 item. So, again, you have more experience in testing than me, but from my point of view, that's a decent message because it's reinforcing, the thought process of pop returned the last item from the stack.
It works, but I think it's a good point. But yeah, I think specifying single item is slightly better because with last item, you don't know how many items there are. Like, it's a little bit subjective, to be honest. You're definitely right. It still works.
Okay.
But yeah.
So let me do .pop here. Should be undefined.
Mm-hmm.
Here we can push 4. We can do .pop, and it should be 4.
Mm-hmm.
And then we'll do one more. So pop should return
I would
And
say
just to keep you happy, I'll do here should return the item pushed to stack. Is that okay?
sure. In this
here,
case,
do you want this? Yeah, go ahead.
Let's use the word when. The nice keywords to use are should and when and if. So pop should return, on line 106.
Yep.
Pop should return the last item when item is pushed onto stack or something. I mean, you can see it doesn't really make much difference, but it's a small thing. So if you can do it, you might as well, because it's a convention, you know?
Okay. And then all we have to do here is this,
Right.
and that should return 8.
And since you're using 2 items, it might be nice also to specify when 2 items are pushed to the stack.
So pop should return
The last item. When
instead of the last, could we say the second item pushed to stack, or do you want to make this string longer?
Yeah, I'm happy with either.
Can I delete this then? So the second item pushed to stack.
I would say the second item should return the second item when 2 items have been pushed onto the stack. Just to keep with that should when kind of convention.
Very good. Okay.
Yeah.
And I believe that is all the cases for pop, if I'm not mistaken.
Yeah. Yeah, and in this case, this is where I went back in my own code, because 2 of these pop tests are exact duplicates of the push. So I kind of went back and I combined the 2.
This is what I was thinking as well
Yeah.
when we were doing the push, because we're also popping to test the push method. So, but that's fine. I think the main point from this, I guess, long tutorial is that I take away and people take away that you just need to be meticulous with your testing and make sure each of your methods is tested and works as expected.
Yeah, that's right.
Whether you combine some tests or not, that's up to you to judge, but each method should be tested and you should get the expected result. Otherwise, you need to go and fix it.
Yeah, you're right. And we might not do this now for the sake of time, but in general, tests are code and they should be treated the same as code. So you should go back and refactor them if there are obvious places where you can refactor, you know?
Yeah.
So yeah, that's why in this case, I refactored. And yeah, basically, if since we have basically 2 tests that are exactly duplicate, we refactor those, we might have to change the naming a bit. But yeah, I think you get the idea, hopefully.
Okay, very good. Shall we move on to the next one?
Let's move on, yeah.
Okay, so here is the next file that we're going to be testing. Now I'll run through the function so that you understand what it's doing, and I'm reading it first time as well, so this might help your mental model too. We have a function that has a variable here which is false. This function returns the execute function here. The execute function expects a bunch of arguments. There is no specific number of arguments listed here. And if has been called is still false, which means if you haven't done anything with has been called, then has been called equals true, and you return the callback function that you passed in as an argument to the outer function, and you pass in the parameters from execute that you pass in on the second iteration.
Yeah.
Now, this is actually using something called closure. So if you're not 100% sure on how this works, make sure you look up closure. I believe, Spiros, you have a blog post, an article on functional programming, and you talk about closure in that, or am I mistaken there?
It's a blog post on functional programming, but I don't actually cover closures. They're a prerequisite for it. So
that's fine. There's lots of information online on closure. You can read up on it and understand how this works. But okay, so should I run through what I believe we would need to test here, or do you want to start, give us an example, and then
Let me say some more about this first. So first of all, this is using something called functional programming, but this could very easily be a class instead. You could have a class named onlyOnce that you initialize with a function, and then when you call the method or something, it runs your method. And the idea here is that we pass a function to onlyOnce, and it will only ever execute once. It's a bit more of a complicated function that you would write, but I wanted to move on to testing some side effects that might be a bit more complicated to test. Yeah, okay.
I will just say, I think to anybody who understands Clojure, this will make sense to you. If you don't understand Clojure, this might seem a little bit complex. So read up on Clojure, and maybe, to be honest, I don't think you need to leave this video because it's teaching you generally about testing, not specifically functional programming. But maybe after this video, feel free to go and read up on Clojure to get a better understanding of what this is doing. But okay, with that in mind, shall I create the test file and start thinking about ways to test it?
Yeah, go ahead.
Okay. Fantastic. All right, so in terms of what to test, first of all, we need to test. So this is not in order of precedence. This is just the thoughts that come to my mind. We need to test that the callback function is correctly executed with the arguments that are passed in to execute.
Mm-hmm.
We need to test that you cannot execute it twice, so that has been called actually does change to true inside its own lexical scope.
Mm-hmm.
And would we need to test that the callback function executes regardless of the arguments you pass in, or is that a different test? Because I would assume that's you making sure that the callback you do pass in can accept the correct number of arguments that you then pass in to execute.
Yeah, okay.
That's a bit of a tricky one for me.
So you have great points, and I think you've hit the majority of the tests that I would write. Is it right if I explain my thoughts on this as well?
Yeah.
Okay, let me see. So yeah, a few things come to mind. First of all, when you call onlyOnce, this is one of the ones that I also didn't think straight away and you didn't mention, but don't feel bad. This was like the last one I thought of. But when you call onlyOnce, like your callback should not execute. So I had the test for that little edge case, just in case.
That makes sense.
Yeah. And then other than that, I think you've hit the nail on the head for most of them. You just want the common cases and do they work properly. So I had a test where I tried executing my callback function, but the callback function didn't accept arguments. So I didn't want to bother about the arguments. I just wanted to make sure it was executed. A small distinction here, and again, this is subjective. You could do both in one time. You could have one test where you have your callback function and you check has it been executed with the correct arguments. Personally, I like to be a bit granular with my tests. I like to see, has my callback been executed? The arguments is a separate test. It's subjective. Small side note there. So anyway, so one test, has the callback been executed? Another test, has it been executed with the correct arguments that I've also passed in?
Mm-hmm.
And yet another test, does it only execute once? So those were the 4 tests I had overall.
All right. So first of all, let's check that when you call onlyOnce, it doesn't execute your callback. Would that be an acceptable first test?
Yeah.
Now, in this case, do we need to use describe, or can we have just the test function?
Since we've learned about describe now, I always tend to use describe.
That's fine.
Yeah.
And we'll go with onlyOnce first. And then we'll do another describe.
Oh, I don't know if we need another describe.
We don't. Okay, that's fine. Yeah.
Realistically, what you do, to be honest, let me qualify what I said. You write describe if you want to refactor. So if you have one single test for onlyOnce, just write a test. But if you have 3 or 4, instead of repeating only once at the start of every test string, refactor it into a describe. Does that make sense?
That's fine. That makes sense. So in this case, we're testing callback doesn't execute when you first call only once.
Okay, so do you mind if I try to change the string a little bit?
Sure.
Let's try and change it to starting with should. I think is usually good to do. So I would say should not execute callback when only once parenthesis function is called.
Okay.
Oh, sorry, the function.
You don't need function.
I mean, like,
just like that.
No, I mean, it's a bit tricky to describe. In only once parenthesis, type fn. Yeah. And then you might want to say, if that makes sense. So should not execute the callback
It
when...
makes sense.
Yeah, okay. If that makes sense, that's good.
Yeah, that makes sense. And then we do this. I'm just going to have it so that all the code is showing, but it might look as though some of the indentation is wrong, but it's fine. So...
Sorry, let me say something
fine.
here as well. I'm not sure if you'll be able to do this test because you need a concept that we haven't described yet. But if you want to have a go, feel free.
Let me
It's
have
up
a
to
go.
you.
So first,
Right.
we're going to return execute. So we simply do, can I type it execute?
Feel free.
Fn equals only once. And so here's the only thing. We need a callback function. So is it okay if I just code a very simple callback function like const fn equals like...
Okay, let's not use arrow functions for the audience in case, their language doesn't have arrow functions.
Okay, that's fine. We'll just do... So here's the thing. So that all the tests can utilize it, is it okay if I do the callback function out here? And I'll just do a very simple one. Function fn. It needs to accept arguments, actually. So let's do x and y. Return x plus y. Or would you want it to be more complicated than that?
I'll leave it to you. Yeah. This is a bit of a cheat because obviously, yeah.
And then what we would need to do is const... Okay, so... So in theory, I'm just going to name this result for a second. If we do expect result to be, and here's, could we do expect type of result dot to be function?
Yeah, just gives you the capability to do something like that. I don't remember the exact syntax, but yeah, you can do that.
Would that be the way you would do it?
Actually, what you wrote might work directly, right? Because type of triple equals function. Yeah.
Yeah, like that.
So actually, yeah, you could do that. I was thinking just gives you utilities to do this kind of stuff directly, I'm pretty sure. But yeah.
I'm going to test it. I'm just going to run it and see if it returns true.
Okay, now while that's running though, think about it. What is this going to do? And does this tell you whether your callback has been executed or not?
Well, to me, yes, because if it executed the callback, it's possible that it would return a number. Well, no, actually, it doesn't really tell you anything, does it?
No,
because
it doesn't really, because you could execute your callback 1,000 times in there. You could put it in the source code and you get me, your test would still pass,
I get you. Yeah. So in this case,
well, this is unfair though, because you don't know the concept yet.
what we would need to do maybe is figure out whether it returns function execute somehow. But you tell me.
Ignore it.
Tell me because, okay.
Basically, we use what's known as a spy. We pass in a spy, and a spy is a function that your test frameworks provide for you, so you don't have to do it yourself. But essentially, it's a function that records whether it's being executed or not. So how you could do it in your function is you could have like has been called equals true. Okay, actually, it's a little bit complicated. I'll leave it for this simple example. I won't explain, but let's just say, you create a spy which remembers whether it's been called or not. So just gives you a utility. So your callback, I would have a line something like const spy equals jest.fn.
Here, somewhere else, right? So sure. Const spy equals jest.fn,
and then parentheses.
And then we pass in spy.
Yes, and then add parentheses on line 9. Yeah, so this creates a spy, which again remembers whether it's been called or not.
That's fine.
So then you do the thing.
Goodbye, callback function.
Yeah, good attempt, but that was quite unfair. But yeah, and then you type expect spy dot not dot to have been called.
Sorry, expect spy what?
And then outside of the parentheses, before to be, just delete the rest. So have expect spy dot not dot to have been called.
To have been or to be called?
To have been called, I believe it is.
To have
parentheses.
Been called. Okay.
Yeah, so that's how you would do that. Okay.
That makes sense. So spy is the callback. Now, why name it spy?
You can name it what you like.
And not callback, because that, again, I'm not a tester like you. So to me, coming from a regular programming perspective, naming it callback means that when I see my, on the terminal, like what it's logged, it's going to let me know true if the callback hasn't been called. And it says here, should not execute callback when only once fn is called. It doesn't say should not execute spy.
You can name it callback.
But it's not a convention when it comes to testing, is it?
I don't think it's a convention. I think it's just what I personally do.
That's fine.
Because it's a spy function, so I label it that, but it's the same thing. Whatever makes sense to you.
So in this case as well, we don't need this, do we?
No.
Because we're calling only once with callback, and we're just checking if callback has been called.
Yeah. So that's how you do that one. Yeah.
Okay. Let's write.
So this is a new concept of using spies, and they're very common for the things that you're seeing here, like with side effects.
It makes sense.
Yeah.
Yeah. That's fine. That's fine. So the next one could be, can we test, first of all, that callback does get called? The test after, can we test that callback can only be called once?
That sounds good. Let's do that.
All right.
And just so you get a bit of a background, your testing framework should show you all of these capabilities. They're nothing special.
Yeah.
As far as I'm aware, every testing framework or library has spies, or you can get packages that have them. And the kinds of things you can do with them is you can test whether they've been called, how many times they've been called, what they've been called with, and things like that. So pretty much everything we need for most tests,
Okay, very good. So this one could be called maybe should execute callback when only once is called, followed by execute. We need to say that it's called twice, Oh, I know. When the returning function from calling only once is called. Would that be acceptable? I don't see that as too long.
I think that would be acceptable because it makes sense to me. You could write it a bit more concisely at the fear that it might be a little bit more complicated. So it's up to you which one you use. But what I used is I used only once function and then parentheses again should execute the callback.
Okay.
Does that make sense?
That makes total sense. Yeah.
Okay.
So should execute callback when only once is called, like that. I know that because of the...
Without arguments in this
spacing.
case.
Without arguments, okay.
Yeah, because we're calling it in this test without arguments. But yeah.
Okay, that's fine. So we do this. We need to have... I'll call this fn2 or fn return.
I would just call it execute to match the source code, but whatever you want is fine, to be honest.
Yeah.
Okay, and now you don't know the syntax. Oh yeah, sorry, you still have to do that.
Yeah, so, and then would I do expect callback to have been called?
Yeah, so you don't know the syntax, so let me tell you about that. So that would work, but I think it's better to do to have been called times 1. So,
So how do I write this? Just simply times 1 or?
So you add the times at the end there.
Here?
Yeah.
As the word?
Yes,
or,
with a capital.
Okay.
Like that.
Times.
And then the number. Yeah.
In here?
Yeah.
Okay. To have been called times 1. Ah, okay.
Instead
so
of
the next
1,000 times, Yes.
Yeah. Yes. Okay, so that's this test done, correct?
I think so, yeah.
All right, very good. Now, as far as I understand, we can't execute this twice because you have a variable that has been changed to true the first time you execute it. And under the same lexical scope, that variable is true when it checks whether if it's true, do not execute the function, basically. So this should also return to have been called only once. So should execute callback only once.
Yeah, naming is hard.
Yeah.
Let's see.
We've got 3 calls there.
I would say something like, yeah, what do you say? Something like should only execute callback once when execute is called multiple times. I don't know. And then you try to make that shorter. Do your best.
You only execute callback once when only once. Yeah, I mean, it's fine. We could make it longer by saying when the returning function of only once is executed multiple times. Is attempted to be executed multiple times, but that makes it longer.
Just say should only execute callback once when execute is called repeatedly. Just say something like that. But yeah, naming is hard, so you do have to spend some time making this.
Yeah, that's it. Okay. That's fine. Okay. And that should return true. Is that correct?
Yeah, the test looks good.
And is there another edge case that you would test for?
So let's test that it's called with the correct arguments. If we pass in arguments.
So using the same, the spy functions that you get from Jest, is there a way to add arguments?
Yeah, you just say to have been called with, and then in the parentheses you add the arguments. Thankfully it's quite simple.
So to have been called with, and then we can add like 2 numbers, for example.
Yeah.
And do we need to add anything here or here on the call side?
Yeah, you need to add it in execute.
Okay, that's fine. Okay. That's quite simple, actually. Jest seems like
Yeah.
a really good testing framework because it gives you all of these utilities to use, which is great.
So I love Jest, but yeah, I'll just say here that I'm pretty sure like pretty much all frameworks probably give you something like this. At least the ones I've used. That's not, yeah. So this isn't what sets Jest apart, but I still think it's really good. Jest, I mean.
All right.
Yeah. And as we can see in the bottom right, the tests are passing.
Yes. Let me expand this. Okay, this is just
it's fine.
Code Sandbox being a little bit buggy, but you can see that they all passed. That's fine. Fantastic.
So once again, to summarize, we have a function. We tested a few common cases that it works. Well, in this case, we tested the common cases that it works. We don't have like repeats of the common cases. Because do we need that for confidence? In my opinion, no. With the test we have now, we're confident that it's working. And also we tested a few of the edge cases, again, to be confident that it's working. So that's all. Okay, before I talk some more, before I summarize this side effects section, any more questions, Nick?
No? For me, this makes sense. The only thing I will say, and this is coming from the point of view of, I've been learning to develop in Java, using JavaScript for a while now, but I haven't had as much experience in the professional world as Spiros. And I also know that certain topics can be a little bit challenging for certain people. I have a feeling there might be some viewers who don't fully understand how this function works. So the two things I'd say is research closure, and perhaps do a little bit of research on partial application or currying. This isn't exactly that, but it works under the same concept. This is returning a function. So, you're calling onlyOnce with a callback function passed in as an argument, and then it returns another function that expects more arguments, which, when you call that, calls your callback function with the arguments that you pass in. So that's all I would say. If you're having trouble understanding what this is doing, research closure and perhaps partial application / currying, because even though they're not exactly the same thing, they'll give you a lot of examples that will help you understand what this code is doing. Is that okay to say, Spiros?
Yeah. Okay, so along with that, Nick gave some great examples of what to do to understand something like this. But just from a testing perspective, you don't actually need to worry about understanding something like this. The point, at least for this session, not that you shouldn't go on to do that, but for this session, the point is that some code is more complicated than other code. But basically, don't worry about it. As I hope you can see, this code wasn't too difficult to test. Yes, you have to understand it, that's fine, but the tests weren't too bad. And same thing for the stack. The tests weren't too difficult, or at least it's up to you, Nick. What do you think? How was the testing?
The testing wasn't too difficult. I think, if anything, I remember when I was learning, when I was sort of still a complete beginner programmer, because my brother's been developing for a few years longer than me, he had sort of instilled the idea of clean code to me from a very early stage. So I would, on my spare time, research and watch videos from Uncle Bob, and research and read articles on clean code and structuring code well and so on. And a lot of the code examples I would give made no sense to me, but it still helped me progress and helped me understand how to better structure my code as I was learning more and more of the syntax. So even if you don't understand all of these functions, the main takeaway is that you get a good idea of why testing is important, why you should learn it, and how to implement it correctly. Whether you can do it straight away or not is irrelevant.
Okay, yeah. Okay, so very good points. To focus on the testing specifically, so these tests weren't too bad. But, at least in my opinion, they're a lot harder than the previous tests where we did pure functions. Would you say that, especially for stack?
Absolutely, yeah.
Yeah. And again, this is the problem with unit testing. Good tests depend on good code. if you can write, if you can write pure functions primarily, which you should be able to do, and in the worst case, maybe a bit more of these functions with some side effects, that's pretty easy to test. But if we go on to testing input-output, and especially the bad code examples at the end, like there is nothing you can do. Tests are going to be horrible. And it's because the code doesn't lend itself well to testing. It's not because testing shouldn't be done or because testing itself is horrible. So I hope that makes sense. Hi there. So we actually had to stop the recording yesterday, but we're back again today and we'll continue straight from where we left off. We're going on to section 3, the I/O. Okay, so let's start by introducing I/O, which stands for input-output. So how do we write tests for this? It depends. It depends on, because I/O is difficult to test. I/O is stuff that our programming language doesn't have baked in. Something like the DOM, for example, the document object model, or databases. They're not part of the programming languages that we use. They're not there. So if we were to run them without having something special that allows us to do so, our program would just crash because, it wouldn't understand what we're talking about. So that's why we have 3 main ways of testing I/O. One way is to have some sort of replacement environment. So for example, for frontend, where we work with the DOM, the document object model, Jest provides a little utility called JSDOM, which is a replacement DOM. We can actually run our front-end code as though it was on the browser, and it will do everything normally and it won't crash, and we can make assertions on it. So that's really good. Same thing if you have a database, you could potentially have a package, a library that you pull in, and it's like a fake database, but you can still use it in all of your code. And again, you can run your code on it. You can do assertions on it at the end. So if you can do that, that's great because you can run your code properly, which gives you the highest confidence that it works. If you can't do that, you've got the second option, which is you can mock things or monkey patch things, which means like basically you intrusively replace your functionality with something fake that you have created so that your program doesn't crash. And then like we saw in the spy example for the previous example, you assert that it's been done properly, something like that. And then the third option is if you can't do either of those two, then you just can't run your input-output code. Your program would crash. So instead, what you do is you don't test it. So say, for example, you have some functionality here with some I/O included over here. As we said, you can't run that. So all you can do is you extract the I/O to a separate place, which you don't test, and you just keep your functionality and you test that. So those are your options. Okay. So let's start with replacement environment, which is the thing you want to do if you're able to do.
Yeah. So that implies that we run a test. Obviously, the test appends something to the DOM in this case. Let's say we're testing appendToDOM. Before we run the test again, we need to remove that item from the DOM in order to be able to append it again. Correct?
So what Nick is talking about here is with these I/O things, you've got like anything you do, like if you change the DOM or you change the database, it stays that way. It doesn't just reset after every test. So yeah, this is the first kind of test where we're going to need to see that we need to clean up after ourselves after every test. And this kind of thing is something you're going to need to do all the time in your own code.
Fantastic. Are there any testing frameworks that clean up for you? Just for if people aren't using Jest, is there a possibility some testing frameworks will automatically do the cleanup or
it all depends, because something like this, something like a replacement DOM that we have here, Jest has this built in. Maybe Jest could clean up after itself using JSDOM. Like it could be programmed that way. It's not programmed that way, so we need to still do it ourselves. But the point I'm trying to make here is if, say, your database package is some third-party thing, like your test framework isn't going to know about the third-party thing to clean up after it, if that makes sense. Like they're not related, so it wouldn't automatically clean up after it for no reason. Well, perhaps I'm just speculating.
Okay.
But
yeah. Okay, very good. Shall we begin with the tests?
Yeah.
All right, I'm just going to copy this to make it easier to import. So import this.
It's replacement environment.
My bad.
The file is
Yeah.
called.
Yeah. Let's begin by adding a describe, as you've mentioned a few times. We'll have a message and then a callback function. Let's get to the message in a second. Let me write the first testing function. Okay. Which would you like to test first out of all of these?
I think let's go for the easy one and build up. Let's go for toggleActiveClassOnBody.
That's fine. So there may be some people that don't really know much about the DOM or haven't worked with HTML documents. Maybe they do backend or from a different language. This basically just grabs the body element of a web page and either adds the class active to it or takes away, removes the class active. And a class is just a way for you to reference that element, and it's used for various different reasons, primarily for CSS. So you don't need to worry much about that. This is just like a little ID that's added or removed from an HTML element.
Yeah, so to expand on it a little bit more, yeah, the code is relevant. It's the testing we care about. This particular thing, as Nick said, grabs the body element. And if it has the active class, then it removes it. If it doesn't have the active class, then it adds it. That's what the name toggle tends to mean. So very simple stuff.
Yeah. So we need to write a test to check that it does actually add the active class and it does actually remove it when removed. So we'll need two tests for this, one for the adding and one for the removing. Yeah?
Yeah, that sounds good to me.
Okay. Now, I know you mentioned this as well, how Jest won't know whether this initially has it or not. So it doesn't reset it automatically. It doesn't clean it up at the end of each test. So would it be valid in this case to have an if clause saying if it doesn't have it, add it, and then check if it's added it? And then if and so on, basically. Like, would that be valid or not, because you're 100% sure that it's going to start out without that class existing?
It's a great idea. I like that you're trying to think of these solutions yourself, but there is a better way to do it, thankfully, with these test frameworks.
Okay.
So first of all, let's start simple. Let's just do a test, which we'll need to clean up, but let's ignore the cleanup for now. We'll do the cleanup for the second go. So for now, just so we know it's going to start with the body element not having anything. So let's just write the test for adding it first.
Okay, no worries. So let me write the code and then we'll write the string. So toggleActiveClass, and then I'll just get the actual element. Actually, if you don't mind, I'll do document.query selector with a dot, what was the class name? Just active. And then expect result dot to be true. Does that seem okay to you?
I'm not sure that would pass, actually. That's the first thing. And the second thing is, I don't think that's specific enough for us.
Right, okay. So I can see the mistake I made here. This would get every element in the DOM with the class active, but we need to check specifically if the body element has the class active.
That's right. Yeah, so that's one thing which you picked up. That's really good. Let me make a point here.
And yeah, go ahead.
the point about your tests, which you need to constantly be thinking of, and rest assured, I make mistakes like this as well, and I have to catch myself, is does this test give me confidence that my code is working? And in this case, not necessarily, because the test could have added the active class to the wrong element or whatever else.
Yeah, of course. Yeah. Okay, so in this case, we can just do this specifically. And we need to check whether it includes the active class, correct?
Yes.
Is the syntax .text content for this? Because
for this particular thing, it's .contains.
.contains, yeah.
Yeah. And then it was just a class name. Yeah, parenthesis class name.
That's fine. I haven't used this before, so thanks. Okay, that's fine.
Yeah, so that looks
So this
good
is
to me.
now, that looks good, yeah.
Yeah.
Now at the end of this, we would have to toggle this again to make sure that it's turned it off for the next test.
Yeah, that's one way you can do it. It's a valid way. So basically you have your test cleaning up after itself.
Yeah.
Why don't we start with that actually? There is a better way to do it, but we can get to it after the second go when we naturally refactor. So I think this is good enough. Well,
so I remember that you mentioned you like to start your string with should. So could we say should toggle active class on in body element? Is that okay?
almost. At one point, I might have started with that as well. And then you'll catch yourself later. So, you know, it's not like you wouldn't see this mistake. But the second test is going to have exactly the same name. For this reason, we should be more specific instead and say something like should add active class on body element. You know?
Should add active class on body element. That's absolutely fine. I understand.
And maybe we want to be even more specific, like
when
it doesn't have the
this
class.
function is called once, for example.
When it doesn't have the class, something like that, you know? Yeah. Does that seem okay?
Yeah, that seems fine to me.
All right, great. While we're at it, let's add the describe. And what I like to do is just add the function name. But if you have something else you'd like to add.
Okay, so in this situation, would you have an outer function on passed in on the first instance of describe and then another instance of describe for each of the functions in the replacement environment module?
Sorry, let me clarify. I meant let's add the string on the describe.
That's fine. Okay. Would you just give it a generic name? Would you say just replacement environment functions or DOM manipulation?
I would just have the function name there. Like the function that I'm testing is what I normally tend to do. But you can have whatever makes sense to you. And I don't remember if we said this yesterday in the same video for the viewers, but you can also have a describe with like the file name or whatever you want, you know, an outer one. It's just for your organization, and so you can understand what's going on, whatever you like.
Yeah, I actually remember you mentioning this yesterday, but I forgot. So what we're going to do now, what you're proposing is to have for each function, its own describe function. Within the callback of describe, have all the tests.
Yeah. So that's how I like to do it. You don't have to do it like that. You could start every test here with the function name, but I just find that a bit redundant. So
that's fine, man. Yeah, no, I made a slight mistake because I was thinking we were going to have all the tests within one describe, and then remembered that yesterday you mentioned that you should have one describe for each like function to let you know what it's testing, basically. So that's fine.
Again, I just want to make the point that you can decide what you like best. So this is just my preference, but it's all valid. Okay.
Okay.
Yeah.
That's fine. So the next one, we'll add the string in a sec, but it should test if it removes the class active. So technically it's not added right now. So actually I will copy this to make it easy, but I'll call it twice. And in this case, would you have to expect functions, one after it's added, one after it's removed it, to make sure that it was added and it was removed? Or would you say that's not needed because we know it's been added from this test above?
Yeah, good question. So again, this is all subjective, but I try to follow the rule that a test should only test one thing. So my interpretation of this is that we already have the previous test to show that it's active, to show that it adds it. We don't need to retest this in this test. It's subjective though. Like it's all, what's your interpretation of that rule? And this would be my interpretation, you know? So you're not wrong either, is what I'm trying to say.
That's fine. If I may give my opinion, even though it's not as valid as yours, because you have more experience, a lot more experience testing than me, it would seem more secure to test that it's being added and removed within one function, even though we're testing it here. Because in this situation, it's fine, but I can imagine other situations where there could be an edge case where when you run both function calls, something unexpected happens and it might still turn out true when it might not be.
You've always got to balance confidence versus maintainability, let's say. So what you're saying is a fair point. Sometimes you may want more confidence, in which case you'll do what you need to get it. That's fine.
Can I give you one slight scenario that I thought of? So I can think of one example where, for example, you toggle the class here and it adds the class to the body element. You toggle it here again and it removes it, but there is some sort of clause in there that prevents the function from adding the class a second time. I know that's actually fairly common sometimes with DOM elements where things can only happen once. So this might not be adding it at all. So even though we're calling it twice, thinking it's adding it and removing it, the test will result to be true, not because the class was added and removed, but because it wasn't added at all. So if you tested that it did add it and then it did remove it, you would ensure that that is not going to be an edge case. Because if it is, you'll see it because the test will fail and you'll go and fix it. I know the specific function is super simple. It's basically one line and it's not going to do that. But as functions get longer, you may not realize you've added something like that. Because, when you're coding also, you can't remember absolutely everything that you've done, especially the larger the files get. So am I thinking validly here? Or not?
Yeah, it's great that you're thinking like that because again, it's the spirit of testing. You're of all code, maybe you're thinking of edge cases. What could go wrong? Is my code good? Things like that. So it's great that you're thinking about these things. I would like to claim that hopefully this particular point shouldn't be a problem. What you're talking about, if this is actually happening, then you're in a really bad place. You don't want things that you really don't expect like that to be happening. You've got a much bigger problem in that case than should I repeat this test. So I would like to just say, I wouldn't like to accept that as a valid point for that reason. Like you should never get to that state. Your code should be predictable. It should not be doing things you don't expect it to. Now, if it does, if you're in a real code base and you're thinking this could happen in this function, then fine, you deal with it. But otherwise, I wouldn't do it for everything unnecessarily. Because it really should be extremely rare. That should never happen, But great points though. keep thinking of edge cases like that. That's good.
Okay, but no worries. So we'll add it, we'll remove it, we'll check if it contains. This should end up being false, and then we'll check if it's false. And we need to remove this because if it's been removed, it's already clean, basically. So this test should end up being true. Would that be all the tests that you would do in this case?
That would be all, but I don't think we're quite done yet. I mean, we technically
need the string.
That's not what I meant, but yeah, we need the string as well.
Go ahead. What is it?
Feel free to do the string first.
Okay, so should remove class active on body element if it already exists.
Okay, so one thing is we want tests to be independent. We want to be able to run them in random order, right? We don't want them to depend on each other. And the second thing is we don't want a test that fails, that's incorrect, to break like the code base. Because imagine, we might have had more tests on the body element, rather more code on the body element as well. And we don't want, because our code here isn't working. So like you suggested, it's adding the active class, but it's not removing it or whatever it is. We don't want that code to break any other test. That would be a disaster because we might have 1,000 tests in the code base. And this test breaks test 700 and we have no idea why test 700 is broken because we don't remember, test 3 is breaking it. How would we remember that? That would be impossible. So we want tests independent, completely independent. And we want tests to basically be working on a fresh environment every time. So back to cleaning the thing. And one more quick point, because we want tests so independent, we definitely wouldn't want any code that would prevent adding the class again, like you suggested. But we went over that. Back to the cleaning thing. So how should we clean? The problem with how we're cleaning here is if our code is broken, the body won't be cleaned. You know what I mean? Yeah. So that's a problem. So we need to clean, make sure it's done. So instead, I would change the cleanup from recalling the function to just saying document.body.outer HTML is empty string. So we clean everything or something like that. You know what I mean?
Yeah, that makes sense. Okay.
Now, just as a quick note, I'm not sure if that will actually work because I've never done this on the body element. It might not work actually. You might need to, but the other way we could do it is just manually remove the class name. So we could say document.body.className equals empty string. But I hope you get the idea that we just need to clean properly. Will it break if we run? I mean, we can check to see whether it works. Obviously, we could even just quickly read some documentation, but would it work if we run both? I have a suspicion outer HTML won't run because it needs a container element. So let's not worry about it now. Let's just remove the first line.
And what is the method called? Classname.clean or?
Yeah, .className equals empty string.
That's fine. Okay.
Yeah.
All right. And that is the thing is, again, this is very likely to work because it's a very basic function. But from what I understand, you don't want to think about it that way. You want to make sure that there is absolutely no edge case. Like I mentioned before as well, what if this doesn't toggle it off for whatever reason? All right, so let's go on to saveToDatabase. Do you want to give us a quick explanation for what it does?
Yeah, so this code has a very simple implementation, as you can see. This is not what the real code would look like, but here we just want to test the input-output part of it. So, ignore the functionality, it's fine. What we would do here is, normally we can't just run a database in our unit tests. Sometimes you can set up some testing environment where you can actually run a real database. So that's fine. You don't need a fake, so to speak. like your replacement environment is already there. You're running a non-production database. No problem. But in other cases, when you can't actually run a real database, again, like the DOM thing, you need some fake thing that you can run as though it was a database, and then you can check the end result. So this would be maybe like an in-memory database. That, again, same thing, you do that. So that's what we have here. So a difference that we have here compared to the other code, as you might notice, is that we have to pass in the database as an argument. The reason we do that is because there is a difference with the DOM from before. In JavaScript, the DOM is global. All JavaScript can access it, and you do not need to pass it in. There is only one of it. But in other code, databases don't tend to be like that. Databases are not automatically global, and you can't just have one of them. You can have as many as you want, and so on. So this is why you would pass it in. Because if you don't pass it in, then it would be global. And then that's basically bad code. That's what you don't want to do. It's one of the core programming principles, the principle of least knowledge in this case, things like that. So I think I'll stop there. But yeah, you have a fake database that you can act on. That's the idea.
If you don't know what he's talking about, programmingduck.com, clean code principles.
Yeah. Yeah, they're very important.
Little plug there. All right, that's fine. So the first thing we would need to do here is create a mini fake database. So I guess I'll just create an array. Is that acceptable?
Yeah, let me make a point on this. Yeah, so normally you wouldn't be creating these fakes yourself because it's a ton of work to code a fake database that actually works properly.
Yeah, so because also sometimes data includes multiple lines of metadata basically for a user or whatever it may be. So I understand that.
Basically, a fake database would have a ton of methods and it would actually need to work like a database does.
Yeah.
So we won't do that. We'll just create a very simple fake database. It will be a JavaScript object with a method called save. Like that's it. Nothing. But yeah, so we do that then?
That's fine. Yeah. So const fake db. And you want a method called save. We'll do that in a sec, actually. First, we'll have an array where we push the data into.
That's fine. That can be our database.
Yeah.
The store for data.
We'll just call it user data, if that's okay. It may not be a user, obviously, but whatever. And we'll have save, which is a method. And we need to get the data.
Okay, you forgot a comma there. There you go.
Is that okay?
Yeah. To showcase the example, that's good enough. Yeah.
Perfect. Okay, so we've got our fake database. So we need to check whether it adds data to the database. And then we need to check, the way we do that is we check whether after we've called the save method once, or the function rather, whether it's added the data to the database by checking the database itself. So would we do, let's grab the function name. From what I recall, the first argument is the data. Mm-hmm. So the data can be anything in this case. I'll just do a string called data1. And the database is fake db. Now that should work because the method you're calling on fake db is save. Yeah. And we've created that method right here.
Yeah.
So that should have added data1 to user data.
Mm-hmm.
Then we can do const result equals fake db.user data index of 0. Would that be okay? And then we can do expect the result to be. So here, do we want to add the exact? We want to add the exact string. Actually, be the best way to do it, not just truthy or faulty. Because we want to make sure that it's actually added the correct date.
Yeah, I'm happy with that.
Okay.
Okay. Yeah, I'll let you continue. Is that all?
I would assume we need to clean up because
Right.
I would assume we need to clean up basically. And we don't want to be indexing index 1 on the next test and so on.
Okay, so before that,
yeah,
we forgot to put this into an actual test. So let's do that quickly.
we did.
Yeah.
All right, fantastic. And here, string could be should add data to the database. Is that okay?
Yeah. Yeah, it's good enough, especially for this very simple and contrived function.
All right, fantastic. We need to clean up the database. So would we do this on the describe method, and then we would put in the function that cleans it up, right? What was it called? Let me check.
So let me stop you there. Yeah.
Yes.
So in real code, we would need to clean it up because the fake database would probably be some package that is mutable. It would change every test.
Can I pause you there for a sec?
Yeah.
I was actually just thinking that we should extract this outside of the testing functions to make it a little bit more like a real database. And therefore, it will require cleanup, and we can use these to clean it up.
This is a great point. And if you were to do that, then yes, you would have to clean up. But since we have it in one test, right now, I think that would be unnecessary. So, right?
Well, I would also propose having one more test, testing, pushing in, calling the function twice or 3 times and checking that doesn't break.
You could do.
So if it's a single test, that's fine. But to be really meticulous, that's what I would do.
Okay.
So in that case, I would extract this. I would assume extracting it inside the describe statement, since it's part of the function we're testing, is the way to do it, correct?
So in this case, what I would do, because you have a good point there, you're doing it well. This is how you would definitely want to do it for a package that you pulled in. But in this case, literally, I would just recreate the whole thing from scratch. Because why go to the trouble of like intrusively resetting it? Does that make sense?
Yeah, I guess so. I mean, it makes sense, but I don't know. I still prefer this way. I feel like it's cleaner having a single database than recoding the database for each test. I feel like that almost defeats the purpose of
So you
testing.
could do it. The reason why I would recreate it, again, this isn't, if it was a package, you're definitely on the right lines.
Mm-hmm.
But, it's good to have immutability where possible so that silly mistakes can't happen. Because imagine we made the silly mistake and we didn't reset it properly. It's unlikely, but there is a non-zero chance that we might do that. But if we shotgun reset it, if we recreate it, no problem. And it's such a small thing that I would definitely recreate it in this case. Like, it's not going to be a performance concern. Does that make sense?
Okay, man. So in this case, you'd ignore the before each and after all calls, and you'd simply recreate the database for each test. So if we had another test testing, pushing in 2 pieces of data and doing something like this, that's the way you would do it in this case.
You don't need to change the 0 index there, but yes, otherwise, yeah.
Yeah, because I'm checking if data 2.
Oh, sorry, on line 54, that will still be on index 0.
No, it won't, because we're pushing to the array.
Yeah, we're pushing to the first index, right? Because we recreated the entire thing. We're pushing to index 0.
But I'm pushing twice.
Oh, you're pushing twice. I didn't see that.
There's no point in testing
Okay.
pushing only once, because that's the same as the first test.
Right.
So I'm pushing twice
Okay.
to check whether it doesn't break when you call the function twice. That's all. Again, we know. So here's the thing. I know you're going to tell me, well, you're not an idiot. You can see that there is absolutely no...
No. I just didn't see
no
that.
clause in there.
The test is
Right,
fine.
okay.
Yeah.
I understand.
Right.
What I was going to say is, I know you could tell me, well, only... excuse my language, like only an idiot would not understand that there's no clause here that prevents it from being called twice. But I'm just thinking of, for myself and for others watching who don't have experience with testing, in most real life scenarios, there's going to be potentially more code than just a single line pushing data. Maybe not, but there might be. So it's good to think about these additional test cases.
No, that's great. Yeah, what you're saying is the correct thing to do. You never assume that your source code works. So if you can think of edge cases that are valid, you do them. You know what I mean? So you're definitely doing the right thing. No problem.
And also, there's no argument for the time it takes, because to test this as well as this, you copy and paste, and then you add one more call to the function. It's a tiny, tiny amount of time to add an extra test in this case. So, yeah, I think it's definitely worth doing.
Okay, now minor point I kind of want to make about refactoring here. I think I will take up some of this time, even though we're focusing on I/O. Let's speak about this for a sec. So let's go back to the cleanup that you suggested. Rather, let's start with this. Pretend we had a third test. I don't think we need one in this case, but pretend we did. So would you mind copying an entire test and duplicating it?
Yeah.
So again, you wouldn't do this, but we're just doing it to showcase refactoring. So we have a lot
of third test.
We have a lot of duplicate code here, which is good to refactor when we do. So here's what I would do. Again, this is a new concept to you, so I'll just walk you through it if that's okay. Is that all right?
Yeah, I mean, I understand refactoring code. I know there is the principle of when you have to use something more than twice, refactor it into a single abstraction.
Don't worry, I don't mean that. I mean something specific I would do in this case.
Okay, tell me, because what I was going to say is, would you do this when you're testing? But go ahead and tell me.
Yeah, so the key concept is that tests are also code. So just like you would maintain code and refactor code, you must do the same for tests. So in this particular case, let's use one example. The fake DB that we've got there, we've got it duplicated 3 times. Let's refactor it. There are a few ways you can refactor it. You can use a function that generates the database for you. So you create a function, generate fake DB, and then you call it every test. That's a good way to do it. That's very explicit as well. You know what's going on. You can also put it in a before it's. So this is the part I'm telling you. In case you haven't used this before, let me walk you through that one. So why don't we go to the top of the describe statement? Yeah. And create a variable, write down let fake DB. We want a let here.
Okay.
Yeah. So let, in case you're not using JavaScript, is a variable that you can change. You can reassign. Okay, and just leave it at that. And then in the before it's, you assign fake DB to the newly created database.
Okay, yeah, that makes sense.
Yeah. And now all your functions have access because they have lexical access to fake DB. So you can remove that duplication there. Does that make sense?
Yeah, that makes sense. So rather than having to put it in a function and call the function each time, or a class and instantiate it, you can use before each with jest.
Yes.
Yeah.
Now, which way would you do? Before each or function? And it depends.
In this case, does it really matter? In this specific case? You get
exactly.
the same result.
In this case, it doesn't matter. But the consideration, as you'll gain with experience, is some test files can be pretty long and have a lot of code. So now you're on line 150. You don't remember what's in for each. You have to, what was there? You look up again. Oh, okay, back to the test. Oh, wait, was that there also? Because it might be a lot of things there. So you have to decide, do you want explicit functions that you call at the start of the test? Because they probably make more sense. You can tell what they do. Or before it's subjective. You decide, you see what's best for your code.
I understand what you mean. Mm-hmm. Yeah. Regarding what you said, I would go the way of having a function or a class that is instantiated or called at the beginning of each test, because then by looking at the test, I can immediately see, oh, fake DB is created, and then we're passing it in. Mm-hmm. Now, like we said a few times, we're technically only going to be running 2 tests here. So it doesn't really matter. It's 10 lines of code above. But if it's very long, I'd prefer the other method because I can see it at the beginning of each test.
Yeah, perfectly valid. No issues there. That's fine.
Okay. Awesome. So I can delete the third test. You just wanted me to copy it to showcase your point. Yeah. That's fine.
And just as a final thing about this point, refactoring can go a long way. You might take it a lot further than this. You might take a lot of data and put them in a separate file that you import to use into many tests. So we're not going to go through this now, but just remember, tests are code and they need refactoring and maintenance.
Okay, fantastic. Shall we go into the next function?
Yeah.
So finally, the last one is appendToDOM. Just to run through this a little bit, you create a div element, you give it the ID, my ID, you give it the text content that is the text you pass in as an argument, and you append it to the body element. So just again, for people who don't know HTML, you create an HTML element, like an element that may be viewable on a web page, and you add it to the web page dynamically. This is what this function does. So this element doesn't exist before you call this function. This function creates it. It adds the visible text that you pass into it, and it adds it to the body of the HTML document.
Yeah.
Okay, so what we need to test is whether, when we call the function and pass in some text, whether that div element has been added to the body and whether it contains the correct text.
Yeah.
But we also need to check that div element doesn't already exist, because there may already be a div element with the ID, my ID.
There shouldn't be, because we'll be cleaning up with a new DOM every time.
Okay, so that's what I was going to propose. Do we clean up? Is there some way, some method? So you propose we clean up, we make sure that if that element does exist, it's deleted before and after each before each function call.
Yeah, exactly.
Okay, and would we use the before each method for this?
That's what I'd go for, yeah.
That's fine. Oh, let's add describe here is for save to database. And this one was appendToDOM is what you named it.
Okay, so I wouldn't add parentheses at the end. But, again, this is a subjective thing.
Is that just your personal thing, or is that a convention with testing? You don't add the parentheses at the end.
Let's just say I haven't really seen it with parentheses. So
that's fine. So it's potentially just the convention people use.
Maybe. Like, I haven't examined many code bases for conventions like this, so I'm not super confident in saying that.
Small point I'll make here. This makes no physical difference to your code and how it works, But what Spiros is mentioning is more, you want to try and code in a way that most people are used to, because it's going to be easier for them to understand the code. And if the convention, if what's generally done is to write the name of the function without parentheses, then you should do that too, because it's going to be more like what people expect. Is that correct?
Yeah, and also as a sort of a point, maybe appendToDOM can't be called with empty brackets. So it might be a little bit more confusing than...
Yeah, it could be like a getter where you don't add parentheses. So, yeah.
Or I mean, like, it must have arguments.
Right. So you're saying if you do this, people might not realize that it may require arguments. People might not realize that it requires a text.
Maybe.
That it contains a text parameter.
Maybe. And it's a small thing, but I think the small things add up. So we might as well keep it as simple as possible. But
that's fine.
Maybe I'm wrong, right? Maybe it's just my preference.
That's fine. So what we need to do is check, first of all, if that element exists, and if it does, delete it. If it doesn't, do nothing. So would we do if we can extract this into a variable, but document.query, it's an ID, so it's single.
Okay, so I like where you're going with it, but let me stop you here. I don't recommend this. I recommend we fully delete the DOM as much as we can, not doing specific stuff like this. Because there are
What if you can't fully delete the DOM though?
Oh, we can in this case.
Other tests may rely on certain DOM elements existing. So
no, tests should be independent. If they're not, you have a big problem.
Okay.
Yeah. But yeah, okay, it's great that you're thinking about it. But
so we're appending to the body, so we just delete the inner HTML of the entire body.
Yeah, exactly.
Right? So just like that. Okay. I'm happy with that. And then we run the first test. So let me think about this for a second. I think I mentioned yesterday I like to use a string hello.
Yeah.
Is that valid?
That looks good to me. Yeah.
Perfect. What else does the function do? So in this case, the function should not be allowed to do this twice, because you can't have two elements. Well, you can have two elements with the same ID, but it's not really recommended. So, but the function doesn't have a clause to not allow you to add it twice. So would that be an edge case that you could catch using a test by testing if it appends it twice with separate strings, and then you go back to your function and create a clause that prevents you from appending it if it already exists?
Okay, man. Yeah, great question. Overall, I'm glad you're thinking about these edge cases. In this case, this is not a testing concern. This is a code concern. We would not write code like this because of exactly what you said. You cannot have two IDs. Like, when are you ever going to write a function that you'll only ever use once? I mean, if you do, fine, that solves that problem.
But it doesn't throw an error if you have two elements with the same ID, correct?
The point here is you can't write this function. This is just a fake example to showcase testing, you know?
Right, but my question is, you could use testing to figure out, oh, I didn't think of that issue, but it's an issue. And then you could go and refactor your code, change the implementation of your function to prevent the ability to append with an element with the ID of an element that already exists with the same ID.
Yeah, you definitely could. Yeah. So if you were afraid that this might happen, you would have a test in there, because if it does happen, that is a bug that shouldn't happen. So you want a test to catch that bug if it happens now or in the future. So yes, you're totally right.
Okay. So for consistency purposes, I would write another test here that calls this twice with a second string. Hello, number 2. Here's my question. I don't know whether you know this or we need to test, because it's not something you regularly do as a programmer who knows JavaScript and HTML. But when you do this, does it pick up? It picks up still the first element.
Yes.
With that ID.
Yeah.
Because it's not like a class where it gets an array of all the elements with the same class name. So this would still pass because the first element is still the one with hello.
Yeah.
So this is something that you basically just need to be careful of, basically, right? How would you test for this edge case for someone who doesn't know about this?
Okay, yeah, so you always need to be thinking of these things. So in this case, what we're trying to test is, are there two elements with the same ID? We don't care about the text content in this case, not as much. We care about the... Anyway, so that's the part we want to test. So we ignore the text content, and instead I would use query selector all and see the length of that.
So you pass in the ID here with query selector all, which takes all of the elements with the ID that you've passed in and puts them in an array.
Yeah.
And then you do dot length. So dot length. And could you write the condition here? So result should equal or be less than 1, like it could equal 0, or it could be...
Yeah, great point.
Sorry, less than 2, my bad, less than 2. Could you do it as an expression here, or would you have to do it externally?
No, it's a great point. Yeah, you totally could do that. And as you said, to be true, that would be very valid. But you wouldn't do it that way when you use a test framework.
You could also do it here.
Yeah, you could do that. But you wouldn't do it that way using a test framework, though.
Okay, what way would you do it using a test framework?
So something like Jest provides useful assertions to help you. And what the assertions do is, like, for example, consider if we run this test now, the test will fail. Okay. Now, when the test fails, on the console, it shows test failed, expected result.
Whatever the string will be.
Yeah, expected result. In this case, result will be false. Expected false to be true is what you're going to get in the console, which is not very useful. Thankfully, Jest provides us with some assertions. You can write instead to be equal to 2 or something. It has some numerical expressions. So instead, in the console, it's going to say a useful message like expected 2 to be 3, or it's more useful than expected false to be true, if that makes sense.
All right, so what you mean is that what we could do is result equals the array dot length, which is going to be a number, and it's going to be the number of elements in the array. And then you can do expect result to be, in this case, 1, because we only want there to be 1 element in the array. If there is 2, then we have a problem. So rather than writing the actual, like the comparison operator, whether it's below 2, you can actually do it this way when it comes to Jest.
Yeah.
But at the end of the day, you're getting the same result. Whether you write length should be like equal to 1 and you put result equals true, or whether you do it this way, you are going to get the same result. But I see this is the convention used for jest.
So this is a little bit nicer because also your test name is going to be something should only add one of these elements. So in the console, you see it should only add one, and it would say expected to be 1. It makes more sense than expected true to be false. You know?
That makes sense. Yeah. So this one should only add one element when appendToDOM is called twice.
Yeah.
So that's
something like that. Yeah.
Cool. Now, for now, I'm going to delete this test because we don't have any like clause in the function preventing it from appending it twice.
Yeah.
But that's what you would normally do. So it's good for you to think about it for real life situations.
Yeah, very good.
Yeah, okay. That's fine. I just forgot we didn't add the string here. So I was like, where's the... should add div element with ID, my ID, when calling. Is that an okay message?
Okay, so I wouldn't have when calling appendToDOM because I think that's implied from the describe. So you do something should do that. I mean, you can have it. I'm just nitpicking.
Just that then.
And also, the function is primarily about the text content. So we want to include that message as well.
Yeah, with ID and text content. Hello.
Yeah.
One sec. There we go.
That's fine. Okay, so if there's nothing else, we can move on to the next topic.
Sounds good. So that is this file done.
Yeah.
Which file would you like us to go into next?
So let's go on to mocking, which is if you can't use a replacement environment, then mocking is the next best thing, in my opinion.
Let me just move the Zoom call icons out of the way. Okay, so we have function log hello, which logs hello. I love it.
Okay, so here's the thing with mocking. So we're actually using Node, so console.log won't crash. Node has console.log, but we can't grab that programmatically, so we can't make assertions on it, if that makes sense. And also in other languages, you may not have that. You need to mock the entire thing. That's essentially where you create, you create a fake like the spy we had so that you can do your assertions on and your program can still run. So what we do in this case in JavaScript is, because it's global, we just replace the log function with our own spy. Okay.
Okay.
Yeah, so we have an object called console, which has a lot of methods. We take a method, we replace it with a spy. Now that's actually quite intrusive. That's called monkey patching. We create a function and we intrusively replace that thing. And you can go further. You can replace an entire module. So where we import, like in every test file, you can actually, you need to use something special to do this. You need to use a jest utility thing that tells you, okay, I'm importing this module. And you tell jest, I know I've written this here, but don't do that. Use my fake instead, which has fake functions. And again, now you can run your code. Your code still runs, but it's running with fakes, which is better than the humble object pattern where you can't even test the I/O. Now you can test it with your own fakes. It's more work, I think, but yeah, so that's how it works.
Okay. I understand the concept. I don't understand how we would code this because I don't know.
Yeah, fair enough. I'll have to show you.
Syntax. Yeah.
No problem. So let's go to the test file.
Sure.
Okay, you'll need to
This is
create it,
solutions.
actually.
Yeah. Mocking.test. Not that. Test.js.
Mm-hmm.
And then, so do we import the actual module? Or yeah,
we'll import it. We won't actually mock out the module. We'll just mock. Yeah.
Side question: why are you exporting it within brackets since it's only a single function and not just like this?
Yeah, it's a good question. It's because it's up to you, okay? But what I've done is, if I have a file that's called, say, add, I expect when I import it to give me a function called add. But if I have a function called utilities, I don't expect the function log hello. I expect it to be one of the utilities. So that's why I'm putting it as a named export.
Because you're not exporting the entire file, you're exporting the individual function, the utility. That's why you've done it in
Kinda, yeah.
early braces.
It's just an organization thing.
That's fine. Either way would work, though.
Yeah.
Okay.
All right, cool.
So we've imported it.
Yeah, so I'll need to walk you through it, obviously, because if you haven't used the syntax, well, we could actually do it manually as well, but regardless, let's start a test. You can do the describes and everything if you want to, but we can just start a test as well, whatever you want.
That's fine. We'll do this. Okay.
All right, cool. So inside the test, let's just do it manually quickly, I'm thinking. Create a new spy like you did last time. So actually,
what was the syntax for that?
Yeah, the syntax is const, name it what you want, equals jest.fn. Yeah, exactly. Jest.fn, and that's a function call. So you've created your spy now, and then replace the console.log function. Yeah. So in this case, you would just say console.log equals your spy.
That's fine. Yeah. For people who don't know, console is a property inside the global object of Node, and log is one of the methods, and it logs something to your console. So we're just accessing the property log.
The object, but yeah.
Right, okay, the object, and we are replacing it with something else.
Yeah.
So we're replacing it with spy.
That's right.
Mm-hmm.
Then you do your test, but we won't do that yet. And then at the end of the test, we have to undo. We have to return console.log to the correct function. So what we actually have to do first is we have to capture the log function in a variable. Yeah.
Of course. So we need to do const orig console equals console.log. You can name it obviously something better than this, and then at the end of the function, we need to reverse this. So we need to do console.log equals.
Yeah.
Yeah. Now, could we use that before each and after all?
Of course. But let's not do that. Now you see how it's done manually, but we don't do it manually. Jest helps us do it a lot better. Instead, we just use, you can delete this and start the test again. I'll tell you what we use instead, if you want.
Okay, I'll do another one so we can see both of them side by side.
That's fine.
Let's go.
Jest.spy on.
Mm-hmm.
Yeah, like that.
Console. Function call.
Sorry? Yes, function call.
Yeah.
And then you write console, comma, string, log. So what that's saying is replace the log function inside console with our spy. Yeah. And it auto cleans up.
That's fine.
Mm-hmm.
I completely understand this. For people who are not using Jest or who don't necessarily know, who are using Jest but don't know the syntax too well, this is exactly the same thing as this. So if for whatever reason you're not using this method, which you should be if you're using Jest, you can still do it this way. And if you're using another framework, it should have I'm guessing, an alternative or equivalent method to this. But yeah, that's fine.
Yeah. Okay.
All right, fantastic. Yeah.
So to write the actual test, this is what we do. We've replaced the spy now. That's good. Then we call our code.
Okay, so we've got this, and then we call, what did you need? Log hello?
Mm-hmm.
Oh. And what do we do here for the expectation of the function? So do we do like expect spy or something like that?
Yeah. It's like a few examples ago. Expect spy to have been called once, and expect, yeah.
To have been, yeah.
Yeah.
Mm-hmm.
Sorry, to have been called times, and then one in brackets.
You mean parentheses?
Yeah.
Yeah.
And then under that, expect spy to have been called with hello.
So when you do spy on, it automatically names the variable spy.
No, we still need to do that.
Behind
It
the
won't
scenes.
run at this point.
Right, so we need to actually do const spy equals. Yeah. That's fine. I do just want to emphasize this is more Jest implementation details. It's more the concept of you need to create a way in which you can test the function as it's using console log. You need to reassign console log to something that you can read to check that it's actually done it correctly.
Yeah.
So,
and more particularly, like console may not exist in another language. You need to replace the entire thing with a fake, with a mock.
Hold on, does it have an auto message or yeah, hello? Okay. Oh, you're using hello as well. Nice.
Yeah.
Okay. That's correct. To have been called with hello, right?
Yes.
All right, fantastic.
Okay, yeah, so that's the example. Now, how do you kind of use this? Because, like, I doubt this you could pick this up and just use it in real code. But we can't go into too many details and see tons of different cases. But yeah, that's the thing. If you can't run something and you don't have a replacement environment and you are allowed to mock, you're able to mock somehow, this is how you would test the thing that you mocked. You just need to test that it's been called correctly. So unfortunately, in this case, you cannot test the end result, which is what you always want to do. You can't test that the DOM has the correct results now. No, you need to test that your function has been called with the correct stuff. You test an implementation detail. Does that make sense?
That makes sense. So what were we doing? Adding a string.
Sure, you can add a string.
Okay. All right, so now let me just add a quick string for this. So should log hello to the console. Or should I say spy in this case?
I would just leave it as that. I think that explains what it does.
Perfect. And I can delete this.
So just a quick word on why this method, mocking, can be considered worse than the replacement environment. Two main reasons I can think of. The first one is that we're not testing the end result. And what that means is that if we have some kind of bug in our fake, or if we code the test incorrectly, which in my opinion, this test is more complicated to us to make assertions on than the end result, or for a lot of things, basically, even if our test passes, our code could still be wrong. That's kind of one thing.
Okay.
Another thing,
Yeah, that makes sense.
Another thing that comes up a lot here is that, like, if we have units that talk with other units, there is a lot of mocking we need to do, because say we have unit A that accepts another unit and it talks to it. So now we need to test A and check that it calls our mock correctly. Okay. But then now we also need to go to the unit B and have a separate test for that. Because like we've tested this connection, but we haven't tested this connection, if that makes sense. We've cut the results here. So there's more testing to be done. And this shows up in code. I don't know if I'm explaining it like super well, if you can imagine it. But yeah, in my experience, this happens a lot. So there's more testing because instead of just testing everything in one go, you have one test, you test the end result, you're done. You have the test, you mock this, so you test this, but then you need to mock and test that as well and whatnot. So in my experience, it results in more testing for that. And there is another reason. So to showcase the other reason, I gave Nick some code to paste into this test. So if you wouldn't mind scrolling down now.
Yeah.
So the problem with testing implementation details, which is what we're doing here, we have a mock and we're testing has it been called correctly. This is an implementation detail compared to testing the end result. This is bad not just for testing, but it's a clean code principle. We should never test implementation details and we should have things private for this reason. But the effects show up here as well. So if you consider the test that we have there, we're testing, we've mocked out the function toggle on document.body.classList. And we're testing in our test, have we called that function one time? Okay, so we're not testing the end result, we're testing have we called this function. Now this is a problem because if you scroll up a tiny bit, on line 19, we have our original function. But what if we had the function on line 23 instead, which still does exactly the same thing? But guess what? Our test will fail because the implementation detail is testing the details of our function. We can't change from one to the other without breaking our tests. And this is where testing becomes a nightmare. This is why people say testing becomes unmaintainable, because you change something, but because you're testing implementation detail, you now have, I don't know how many tests that you need to fix every single time you make a change. So this is, I hope this makes sense why this is much less preferred than testing the end result and avoiding implementation details like the plague as much as you can. Okay?
Absolutely, that makes sense.
All right, cool.
All right. Am I okay to delete this and we go on to the next file?
Yeah, let's do that. That sounds good.
Yeah. Fantastic. So now we're on to humble object pattern.
Yeah.
Final section of I/O.
So I think
here you
for
have
this
a few extra
one,
files.
Yeah, I've got more files here to show before and after. I'm thinking let's avoid the code in this case. Let's just look through the code we have already. Is that all right?
Okay. Which file would you like me to go into first?
Let's see. Go to code without humble object pattern first. The first one.
Yeah.
Right. So just to recap, that's when you can't actually test your I/O full stop. Okay. So what do you do? So this is just some fake functionality again, where we have an event listener on the document object model, and when that event listener gets called, then again we do.
I changed it with a capital E, by the way. I don't know if you made any.
Thanks. No,
if you
that was a
added
mistake.
any tests, I would break it. Okay, that's fine.
Yeah. So, and then after that's called, we run into the function handle key down. So what it does? Well, it doesn't matter what it does, but what it does is it does some calculation, and then it writes the results to the body.
Yeah.
So we have an event listener, then we do a calculation and we write the results to the body. And this doesn't matter. The point here is that we cannot test this because we don't have a replacement environment that has the document, and we haven't mocked. So if we try to run this code, it just crashes. We cannot test it. That's the end of the story.
Okay.
So as we said, what do we do instead? Well, all we can do is extract the calculation. We test the calculation separately, and we forget the I/O. We don't test the I/O. Okay, so do you want to go into the code, the other code?
Yeah. So
why don't you go into the logic? Yeah, that one. So here we've extracted the calculation into a separate file, and we have tests for that file.
Yeah.
So the test
That
here would
makes
be
sense.
as normal. This is just a pure function.
So if we go, yeah,
I haven't done anything, but it doesn't
you
matter.
haven't done it. Okay, but you would basically test, like we did with the pure units, basically you pass in an argument, which is a number,
Yeah,
and you check whether the return is the correct equation, which would be number times 4.
yeah. And now the I/O
Right.
code is in its own file, which we just don't test.
Yep.
So that's it. Hopefully pretty simple stuff.
Do you have to put it in its own file, or could you simply just export this function from here?
Yeah, you don't have to.
You're doing this though, so that would break the if you tested it as a unit where you pass in a number, this line would not work.
This is actually a
So-
small change I made. So in the original functionality,
Yeah.
to calculate answer, we pass the event. But into the new thing, I want to separate the I/O and the calculation. So instead, I extract the thing we need from the I/O, and then I call the functionality. In other words, here in calculate answer on line 14 or 13, we're using the event. But in the new version, we're not using the event.
Yeah. Okay. So that's what I was going to propose as well. It would be valid to change this so that you're pulling the number from the event and passing the number as an argument
Yeah,
rather than calculating the number within the calculate answer, because you don't really want the calculate answer to do that. You just wanted to calculate the result of the two numbers.
yeah.
Correct?
That's exactly right. Yeah, you want to separate the I/O from the non-I/O stuff.
Yeah. So we could simply just to change the implementation here, just that. But we would change this to number. That be acceptable?
Yeah, definitely.
Cool. Okay, so that makes complete sense. My point was basically you don't have to create a whole new module, add this function there and export it from there. You could just export, or rather you could export whatever you want from here as long as it's including this function, and you could just import this function into your testing file and test that function individually.
Yeah, in the end, it's up to you. You can organize your code however you like. But yes, if your code doesn't crash, then yeah, you don't have to.
Okay, that's fine. I'll let you continue.
Okay, yeah, so I think that's the end of the I/O section, basically.
Okay, then one more question on my end.
Mm-hmm.
Is there a way to test this function and this function independently? Like, for example, could you create a slightly different implementation of this where you don't pass in an event, you pass in a number, and you check whether it appends that to the DOM, the calculation of this to the DOM, and then you check whether this element has been appended to the body.
Okay,
Like
yeah.
we did with the div element in one of the previous examples in the I/O. Would that be something that you would want to do?
It's a good question. Let me rephrase to see if I have what you're asking right. So are you saying you want to unit test function handle key down, or are you saying you want to separate those functions some more?
Yeah, I'm saying I'd want to unit test this, but as it stands, we cannot unit test it with the event listener because, yeah, I mean, I can't think of how to do that. But what we could potentially do is create a copy where we pass in a number, pass the number in here, and we unit test this, which is a close implementation to this here.
Mm-hmm.
And we check
All right.
that this works.
So testing I/O is always difficult. This could be a large question because it depends a lot on how you organize your code as well, what you export, what's private and stuff. So it could be, but I'll try and keep it short. Let's just say that this code may be private, so maybe you can't unit test it. It depends how you organize it. Because like you have a module that activates this event or something, and it doesn't export the handle key down function. Maybe it's just in there and it adds it. Or, yeah, it's very valid that it might export it, so then you can unit test it. So then the question becomes, how do you unit test this? In this case, you can unit test it, right? Because it does a calculation, and then you can assert, sorry, not in this case. If you were using a replacement environment or you could mock, you could unit test this because you could assert the DOM in this case that does it have the thing? If it does, great. If it doesn't, no. And same thing with mocking. So you could do that. Another answer to this question is you could consider this to be more of an integration test, which is not something we're going to cover today. You know? So
Okay.
I think I'll stop there. But yeah, there are a lot of ways to answer this.
That's fine.
Mm-hmm.
No worries. All right, fantastic. So where do we go to next?
All right, so
humble object pattern IO.
So we did all that. So we're done
did.
with IO in general.
Okay, we haven't looked at this file specifically though.
So that's basically, remember we separated the IO from the logic? That's the other
Right, so
file.
we just didn't look at the file. Okay, so you created a file with just the calculate answer and the other file with just the IO.
Yeah.
That is fine. Okay. The final section here is bad tests.
Yes.
Which file would you like me to open first?
I don't know. Pick one, I guess.
Okay. Bad code it is.
All right. So what are we doing here? Yes. So here.
Oh, I know exactly why this is bad.
Okay. Do you want to talk about it then?
Well, yeah, it's, I believe it's also like the principle of least astonishment. Is that correct? Where basically what you want to try and avoid doing is changing global variables, changing anything that is accessible by other utilities. So right now what you're doing here is an impure function where you're changing the state of your entire program. Every time you call this function, it doubles number. And if there's any other utilities in your program that are accessing number may not be what they expect because of this function over here.
Okay,
so you want to try and keep your functions as pure as possible.
Yeah.
So if you want this to return number times 2, then you should have it return a new number, which is this times 2. You should not have it change the global variable number.
Yeah, great. So you were talking about the aspect of this from the point of view of good code and clean code and things like that. So that's very valid. You definitely don't want to do that. The problem with this as well, though, is that this is practically impossible to test. Because
I can see that too.
If you open the test file quickly.
It's because every single time you call this function, number is a different value.
Yeah, and you can't clean it up. So technically, you could test this if you knew the order your tests were going to run in. You know how many calls you're making. If you know everything, you can test this. Your tests need to run in a specific order. First of all, that's bad because you want tests to be running randomly in random order, and you don't want them dependent on each other for a lot of reasons. One time you might skip one test. One time you might write another test. You might even have your tests running parallel for performance. And obviously your tests would break in all of those cases. So this is basically untestable, realistically. So that's one thing. And this is where I'm saying, where Nick said as well, good tests depend on good code. Code like this is bad code. It's not the test's problem, you know? But yeah, how would you do this? Very simple. Follow the principle of least knowledge. And function double should accept a parameter. And then it should return. It should be a pure function and that's perfectly testable every single time. So that's one example. Nick, if you like, let's scroll through some of the tests, just so the viewers can see.
Here you go.
Yeah. Okay. So just quickly then, in the first test, we append 5. In the second test, we have to append 10 because now our variable has doubled and there is nothing we can do about it. And then finally, you go to the third test, please. Now this test would fail because double isn't 5 like we expect it to be. It's like, you get the idea. It starts at 10. So I think that should be good enough.
And you're calling double twice here. So you're making it 20 and then you're making it 40.
Yeah.
And this is why it would fail. But technically, if you had 40 here, it would pass.
Yeah.
But it's not something you ever want to do. You know, you don't want to be... If you're having to mentally calculate something and it's a different number each time you calculate it, it's not... And it's accessing the same variable, it's not a very good code practice as far as I'm aware.
Yeah. This makes testing a lot more complicated than it needs to be and unmaintainable for all the reasons we said.
Okay.
Okay, so that's that example. Any
Very
questions?
Good. No, it completely makes sense.
All right.
Yeah. Don't mutate global variables.
If it's unnecessary, yeah, definitely.
Yeah. All right. Implementation detail?
Sure.
All right. So here is the module. So oh no, sorry, that's the test.
Right. Okay.
Here it is.
Cool.
You got a function double, and then you have a class with a getArea method, and then another function to toggle the class active or remove it.
This is another really important one to watch out for. Testing implementation details, in this case, means don't copy the implementation from your source code into your tests. All right, for example, let's start with the function double at the very top, the simplest. What it does is very simple.
Yeah.
Next, let's look at our tests.
I was curious, actually, because I couldn't see anything else accessing double. So I was wondering, why is double in this module? What you just said makes sense, I think.
All right. Yeah, so let's move on to the tests.
Yeah, let's move on to the test, right?
Yeah.
Okay.
Here we're testing double. And what we're doing is we're testing is the result value times 2. We've copied the implementation from our source code. Now this is bad, and here is why it's bad. Okay, first of all, if our source code is correct, and it is in this case, and we've copied the implementation of our source code in our test, which we have, then our test passes and our test is correct. Okay, that part's all right. What if our source code was wrong and we've copied the implementation from our source code into our test? Our test passes and our code is wrong.
So what you're saying is you want to test from your source code modules. You want to create a testing file, import the utilities that you want to test into your testing file, but keep them in their original files.
No, what I'm saying is on line 11, we shouldn't be testing value times 2. We should be testing for 10.
Right, okay.
We shouldn't copy our source code implementation into our test. Because then if our source code is wrong, our test still passes. And if our source code is correct, our test still passes. The test is useless. It might as well not be there. It doesn't give us the confidence that our code is correct.
Okay.
You know?
Yeah, that makes sense.
Yeah.
Yeah. I thought you implied that function double is supposed to be from another module. It's irrelevant to this module. And you shouldn't copy like functions from other modules into a testing file and test them all from that combined file.
Mm-hmm.
Yeah.
Yeah, that would be a fair point as well.
Understood. Okay.
That's fine. Okay.
Yeah.
All right. So you're the only one I can speak to right now. Do you see the point for why, in this simple example, it's bad to copy implementation?
Yeah. I mean, this is a very simple example, but it completely makes sense.
Mm-hmm.
Rather than adding more complexity, such as an equation here, just write down the exact expected result.
Yeah.
And see whether the function returns exactly what is expected.
All right. And the reason for that was?
Well, your implementation might be incorrect in the first place.
Exactly. There you go.
So
yeah, so the test always passes.
So you might think, so it might pass, but it's because this is actually what's incorrect.
Yeah.
And a simple times 2 is simple, but it can get much more complex, as we've said many times throughout this tutorial.
Even that, someone could miss that, because what a lot of people tend to do, literally copy paste. If you copy paste, you probably won't catch the mistake.
Yeah.
So that's basically that one. So always test the end result and don't copy implementation.
So I'll just do this. Okay.
Mm-hmm.
Any pointers about the next one?
The rest are exactly
the
same thing. Yeah.
Yeah, I can see now. So you're testing the implementation detail rather than what the exact expected result is based on the calls that you've made.
Yeah, that's right.
Yeah. Okay.
So we're using the toggle function method rather. So that's fine. It's correct. But it's not crazy to think that we might have written down there an incorrect function, right? If we're mocking, it might actually work. Even if it doesn't, we might have written down the remove function because we're rushing or whatever it is. And again, because we're copying the implementation, our test would still pass and we would have incorrect code. So that's why we don't want to copy implementation.
Okay. All right. Sounds good. And finally, shall we go into unnecessary mocking?
Yes. Okay, so we had to take another break. This is day 3 for us now, but we'll continue straight where we left off, and that was the unnecessary mocking example. So in this case, with unnecessary mocking, it's kind of like what it sounds like. If we don't need to mock something, then we shouldn't, because mocking creates additional work that we need to do, and we'll see why in this example here. So just to showcase here the public functionality of our class is the method getArea. That's the part we really care about. In a good test, we would just test getArea. We've already been through this, and we would test the end result of getArea. However, another way we could do it, the bad way, is to mock private helper. So as we saw in the mocking example in IO, we mock private helper. So now the problem is that when we test getArea and we've mocked private helper, we need to check that we've called private helper correctly in the getArea method. So that's one test, and that test is okay. But the problem is that we haven't tested private helper yet. We've mocked it, we've tested that getArea calls it correctly, but we haven't tested that private helper itself is working correctly. And we also need to do that because otherwise our code wouldn't work. So that is the problem here. We need a separate test for private helper. We need 2 tests, not just one. And it would be better, it would be less work if we just tested getArea straight away. So let's look at the test now, if that's all right.
Mm-hmm.
Yeah, and you see what I'm talking about here. So in the first test, lines 10 to 19, we're doing what we said. We are testing that getArea calls the mock correctly. So specifically, we're mocking out private helper that happens on line 12. We are giving it a fake return value. We need to give it a fake return value so that we can check that getArea returns the value that the mocked out function returns, otherwise it wouldn't work correctly. Then we call getArea and we check, has getArea returned the thing we set it out to return, and has it called our spy, our mock, one time? So that's the test for getArea, like with mocking out private helper. And then, of course, as we said, we need an additional test.
And this is the line that replaces the private helper method with the spy.
That's right.
Yeah.
And not only that, but actually these 2 tests are much, like, not only is it 2 tests, but they're also much more complicated. There is more code than just testing getArea directly. Yeah?
Yeah, that's fine.
Okay. And then finally, oh, sorry, do you have anything else to say?
I was just going to say, so when it comes to a really simple utility like this, it's not worth mocking it, basically. You're saying that it's more worthwhile and it's going to save you more time testing directly just the function, even if it's calling another function within itself.
Yeah, so the point for...
the result of another function.
Yes, so the point for this example in general, unnecessary mocking, is don't mock if you don't need to, because in general, this is what you get. You get more work for no benefit. It's actually worse because we're also testing implementation details, which was the last example, which we really don't want to do. Anyway. So we've tested getArea. Now, of course, we need to test that private helper works. So we have an additional test, lines 21 to 25.
Yeah.
Yeah. So that's how it's done. And you might be thinking, well, private helpers should be private. So maybe in my programming language, I can't test it. And from what I've seen, I don't think that's the case. Or let's just say that even in other programming languages and even with stuff in JavaScript that's private, I have seen utilities that allow you to get in there and pull out the private things and test them anyway. So there are ways. And like, for example, in Zest, you can test functions in modules that aren't exported. You know, don't hold me accountable 100% for that one, but let's just say there are ways to test private things. It's a lot of work, and it's like you shouldn't be doing that. So people put themselves through a lot of work for something bad.
Yeah, I have heard as well that I've heard it being recommended by various programming teachers that I've learned from, that it's not necessary and you shouldn't want to test hidden implementation details, encapsulated details. You should only test public API. And if that's not working as expected, then you can go and dig deeper and see what is the issue there.
Yeah. So one last point about this is that's a strong guideline for like at least 90% of the time, maybe more.
Okay.
Now, if sometimes you need to test something private, that's fine. Because if you know what you're doing, you'll do it if you really need to, if ever. Hopefully you shouldn't. But yeah, you at the end of the day, you need to make correct software. These are very strong guidelines, and I've explained the reasons why, but it's up to you if you know you need to break a guideline sometime.
Mm-hmm.
Okay, so that's it. So any more questions on this?
No, it makes complete sense. No worries.
All right, great.
Shall we move on?
Yeah. So basically, that marks the end of the practical examples for this section. But before we completely move on, I would just like to mention one or two useful assertions, useful tests we can do that we haven't actually gone through. So for example, in our pure functions that we had, the first examples, another kind of thing we could have tested is something like an operation on an array or an operation on an object. Okay. We didn't actually do any of that. So pretend we had a function called double array, which doubled every element of an array. Your test framework will give you different ways to test this, but I just wanted to let you know that you can test arrays. Okay, so for example, if you were to write a test line, if you'd like to do that, go under line 25, create a new line. The format would be something like, that's fine, yeah, you can create a test. So the format would be something like expect result.
Do you want me to write it as you're speaking it?
Yeah.
That's fine.
Yeah, expect result to equal. And then you would open parentheses and you would have an array in there. Say an array with the values 1, 2, and 3.
Sure. So that would be like the doubled values. And
that's
you would
right.
Put in an array. Yeah, that makes sense. And in this case, 2b would throw an error, or does 2b not accept arrays or objects as values? Does it only accept single primitive values?
So 2b actually checks for, let's call it reference equality. Okay. Whereas 2equal checks for the contents of your object.
Okay, so basically if we put in an object, it would only 2b like equal to that if it was the same in memory. If it was
that's
referencing
exactly
the exact same thing in memory. Yeah. Okay. I understand.
Yeah.
Whereas 2equal just checks whether the key value pairs or values are the same inside the object or array. Or is it for objects too, or is it just for arrays?
Yeah, objects as well.
Yeah. Okay. Yeah, that makes sense.
Cool. And the next assertion we can do that we didn't talk about is we can check for if our function threw an error. So for example, we might be checking the arguments to see that they're valid and within a particular range. And if they're not, we might throw an error in our function. And if you want to showcase that, why don't you start a new line under line 29?
Yeah.
And again, your test framework will have its own assertions for that. But in Jest, you do something like expect something, rather expect callback. What I mean by that is the function that you're testing, say for example, we're testing add, you wouldn't call add, you would pass in that callback, if that makes sense.
Okay, so you'd pass in the actual function here. The function that you're supposed to be testing, let's say the function we wanted to test was called add, like you said.
Yeah.
We wouldn't call add and pass in the result. We would pass in the function itself like this.
Yeah, that's right.
Yeah.
And
that's fine.
Yeah. And then it's dot, what is it? I have the thing there. To throw. Okay?
Yeah, that makes sense.
Yeah. And then parentheses.
Do these other ones, like to throw error, would that also work too, or is it just to throw?
Yeah. So you have different kinds of assertions to be a bit more detailed about what kind of error you want to throw and things like that.
Yeah.
Yeah.
No worries.
Yeah. So
to throw and then parentheses.
Yeah. So that's fine. So this is how you would do it if you wanted to call add without any arguments. Okay. But if you wanted to call add with arguments, then you would have to write a function that calls add how you want it and then pass in that function, if that makes sense.
Yeah, that makes sense. So what you're saying is we would create like another function here and it would call this function, let's name it like callback. It would call add with a certain list of arguments, basically like 1, 2, and 3, for example.
Just 2 arguments, but yes.
Sure. Yeah, absolutely. And then we would pass in callback here.
Yeah, that's exactly right.
Yeah. Okay. That's totally fine.
All right, cool.
Yeah.
And finally, there are even more complicated tests that you can write for weird cases. Like, in my opinion, you shouldn't have to write many more tests than what we've covered today. But in real code bases, especially since code can get quite complicated, and it happens, it's not anyone's fault, it just happens. You might need to be more creative and combine some of these concepts and whatever, and tests weird and complicated connections between modules. They use the same concepts, but you just have to apply them and be creative with how you apply them, if that makes sense.
Yeah.
All right, great. So that's basically everything about the practical examples for testing for this video. So next, I think we should go over the main points that we talked about and basically summarize them. Basically summarize the theory of what we did today. Is that all right?
Yeah, sounds good.
Okay, then. So a few things that we'll go through one by one. But just quickly, so what do you test? Okay, we've been through this a lot already, but primarily you want to test the public functionality of the thing you're testing. So if it's a module, you test the public functions, right? If it's a class, you test the public functions. You never go in there and take the private stuff because, and again, I'm reiterating here in case some viewers see just this section, they don't care about the practical. But the reason for that is because, one, it gives you more confidence that your test is working correctly. Okay.
Yeah.
And 2, it allows you to change the private functionality tomorrow. Whereas if you're testing the private stuff, and this is a clean code thing, this is the reason itself why we have private things. We have private things so we can change them tomorrow. If you're testing those private things in your tests, then you make a change tomorrow, all your tests just broke. And if your entire code base is like that, tests are going to be a nightmare because anytime you change anything, you have to change who knows how many tests. So yeah, test the public functionality as a strong guideline.
Yeah.
The second thing is test the end result. So as we saw, basically don't go in and copy the implementation of your source code, right? Test the end result directly. And also, as much as you can, avoid unnecessary mocking, as we just saw a few minutes ago. Test the end result, don't test intermediate steps and implementation details. Okay, so the next point is that tests are also code and they should be maintained. So as you do with any other code in your code base, you refactor things when you're testing. You organize your tests appropriately so they're helpful for you. And we've been through that in practical examples. So you might use before each, and those kind of functions, or you might use a function that you call in every test to help you set up the state for the test. You might take common stuff, common functionality between different test files, like for example, data as well. You may have data that you reuse in different test files, and you'll extract it into its own file so you can import it in your tests where you need it. So this is all stuff that you would do with real code anyway, and you should also do with tests when appropriate. All right, cool. So any questions so far?
No, so far that all seems straightforward and understandable.
Okay, that's cool. So the next point is that good tests depend on good code. And this is part of what we try to show today. And I've already spoken a lot about this, so I won't reiterate all the points.
Yeah.
But the main point is that you know how to test now, right? Other than some very rare things you might have to do once in a while, you don't need to learn more assertions or things like that. What you need to do instead is you need to write good code in a way that allows you to test it easily. So this is a good code, a clean code thing. It has nothing to do with testing. Good code is easy to test.
Yeah.
Right? And the opposite is, So as much as you can, try and write pure functions, because you should be able to have the majority of your program write good functions. As pure functions. That's part of the process of becoming a senior developer and writing clean code. If otherwise, you need side effects sometimes, that's fine. But try and make the side effects as self-contained as possible. So for example, with the stack example that we had, that was pretty self-contained. That class made sense. It was conceptually easy to understand and easy to test. Right? It's good code.
Yeah.
And then I/O side effects, like I/O side effects, not just normal side effects. Again, you want those to be minimal in your code base. Like you don't want to have complicated logic, complicated side effects, complicated I/O, so to speak. You want to have, your logic up here, whatever, and then you have a little layer of of I/O at the bottom. Okay, I've calculated everything, now print this to the DOM, or now save this to the database. Isolated, so again, you can test it easily. Yeah? So this is clean code. And so that's it about this point. And what else? The next thing is to have a failing test. We didn't really go through this today. We'll go over it now. The problem that you will find with experience is sometimes you write a test and a few things could happen. A few things could go wrong where your test might look like it's passing, but your code is still broken. So I've got some reasons here. The first one is you might accidentally not run your test. Who knows why? Maybe you've skipped it and you didn't see it. Or maybe the file itself isn't running because maybe you've named the file incorrectly. So now your test isn't running. Whatever it is, your test might not run. So you look at your tests in the console and you see they're all passing, my code's working. No, your test isn't running. Okay. So there are more reasons, but this is why you want a failing test. You want your test to fail first. You want to write your test and you want to see, I've got a failure in the console.
Okay.
Yeah?
Yeah.
For the reasons...
So would you always do this? And would it be the first test? And maybe the error string that you pass in, by the way, I didn't ask this before, but where is it? Did we delete it? Okay. When we write a failure test, in the parentheses of expect error, so hold on, expect to throw, right?
Okay.
Here, do we write a string that is logged as our error string when...
No.
No, okay.
Don't worry about that. You can always look this up, this assertion. It takes like 30 seconds.
So in this case, would you always recommend writing a failure test and putting, obviously, as the description of that test, a failure test or whatever, something to let you know that is the purposely made test to fail?
Not exactly, no.
Okay.
So what you would do, can you please delete line 30? I'll try to explain. So pretend this is your test. Okay. And like this test should pass. You name the test what you normally would. You don't need to change the string. But the point is, and I won't spend too much on practical here. Let's just say that this test needs to fail. Okay.
I get you. Yeah.
You need to see a failure in the console. And there are a few ways you can make the test fail. One way is probably better than the other, but one is like if your source code isn't working, or if you haven't implemented your source code yet, or if you go to your source code and you make it do the wrong thing so your test can fail, that's one way to get a failing test. So your test is correct, your source code isn't correct, the test fails.
Shouldn't you just expect the wrong result?
Yeah, so that's the other way you can do it. Okay.
Yeah.
It's not as good of a way. I'll explain why in a minute. Okay. But yeah, that's the other way you can do it. But the point is you want every test to fail. Every single one. Okay. But let me go back to why you want a failing test. So the points were, and I will come back to this. As we said, for some reason, the test may not actually run. That's one reason. There are many ways why that could happen, but I'll leave it to you to think about. Another one is you might code the test incorrectly, so the test always passes, you know? So this is why. That's actually all the reasons. So why do you want to... We said, how can we make the test fail? We can have the source code wrong or the test wrong. Having the source code wrong is, in my opinion, better. Because, well, here's the thing. One of the problems with tests is that, like, your test might somehow be testing the wrong source code. Somehow. Maybe you've imported the wrong function, whatever it is, you know? It's testing the wrong source code. And this can happen. You'll see it with experience. All kind of stuff can come up. Another thing, as we said, is your test might be incorrect. So your test might always pass, whether your source code is correct or wrong. So this is why it's good to make sure your source code is wrong and see the test fail. Because then you know, okay, my test is failing properly. My test wouldn't pass even if my source code was wrong and my code is broken anyway. Does that make sense? So that's why you prefer that. Now, do you need to do that always? No, you don't necessarily need to do that. What you could do instead, if you imagine we went back to the add function we were looking at before, if you're confident that the correct file is running, you can just say expect my result to be 3 instead of 2. Then you would see in the console, okay, it's returning 2. So you see in the console your code is working correctly.
Yeah.
That might give you enough confidence. You're like, I don't need to put in the extra 2 minutes to break my source code. I think it's fine. Let me just change the test.
Isn't breaking your source code generally bad practice? Because what if I would assume that creates room for error when you try to fix your source code or whatever, even if you, unless, I guess what you could do is create a copy of the entire file, change some of the code there and then test that. But still, I don't know. It makes me feel uneasy thinking about breaking the source code rather than just writing a test that expects the wrong result.
Again, we said why a test expecting the wrong result could be a problem. It might not run in your source code, and the test might always pass regardless of your source code.
Yeah, I mean, I understand that, but...
Well, when you break your source code, so to speak, you don't need to do a lot. You can just go to your source code, instead of returning 2, make it return 3. You see the test fail, okay, now revert it. You know?
However, why exactly would it, if you're calling the wrong function, it seems just as likely to me that when you expect the correct result, the passing result, that it would fail. And then that would, you know, be flagged up and you'd see, oh, that's failed. That was supposed to pass. What's going on there? And then I assume you would look at it, analyze it, and figure out that you've called the wrong function. I guess I'm just wondering why that's one of your recommended practices, because to me, it doesn't seem like as big of an issue in my mind. But again, I haven't had your experience with testing, so
yeah, that's fine.
Yeah.
So it's generally a recommended practice.
Okay.
You also see it in the process of test-driven development, which includes this, and there are good reasons why.
Mm-hmm.
But anyway, let's say that you're right. For the most part, this is uncommon. It's fairly unlikely that you're gonna not even call the correct source code, although it can happen. So we agree on that. But you can see that if it does happen, you're in trouble. Okay, because yeah. But another thing is that your test may be coded incorrectly. So it always passes, regardless of what the source code does. And it's easy to see how. You might have in there expect 3 to be 3. Instead, it should be expect result to be result. That mistake is something that can happen to anyone at any time, anywhere. And again, you change the test fails now, but your source code's still broken, but you won't catch it. And you might be thinking, what idiot would do that? No, because when you're working all day, when you're tired, when you're doing, okay, back to source code, back to test, back to source code, back to test all day, little silly mistakes are easy. That's why we write clean code, to avoid little silly mistakes. They're not rare. Don't think what an idiot. No, this is extremely real. And you're going to make hundreds of those mistakes in your career, just like everyone has. No one is special enough to not make those mistakes, when they get tired. So that's another reason. Now your source code is broken, your tests won't pick it up.
Mr. Robot.
Yeah.
Sorry, go ahead. So is the recommended kind of flow, first you write the tests and you run them once, then you change your source code and check if they're giving you a different result. And if not, then you know that something has gone wrong with your tests.
So that would be my recommendation. You don't have to do that. I explained the reasons for it. And you're a professional as well. It's up to you to make the decision of what you want to do.
That, by the way, visualizing it in that way makes more sense why you would change your source code. Because you've written the tests and you know they're working, but just to be double sure, you just change your source code. Maybe you just change the return statement of your source code and you check if they're now giving you a failure result.
Yeah.
So that makes more sense. So in that case, for good practice, you would only, I assume, change the source code of one function at a time, and you would change it, run the test immediately, and change it back to prevent any accidental forgetfulness of changing it back. Or maybe you change your source code, you go do other stuff, and then you come back and you're like, oh, what did I change? Kind of thing.
Yeah, it's just a quick sanity check. You check, is it working? Cool, okay, revert it.
Okay.
You don't just leave it broken.
Can we do just like a tiny quick example? So if we go on one of the pure units here, we're testing for the add function. So we could test like return, foo as a string.
Yeah.
Check if that fails and immediately revert back to the
that's
correct
right.
value.
Yeah.
Yeah. And if we had multiple modules here, like here, we would only, and let's say, I know in this case, you recommended do not test the private implementation, but let's say we were testing both of these, we would do one at a time. We wouldn't change the return value of this, and then try to revert both of them after. We would do one at a time, again, for like minimal room for error.
Well, you can do what you like, but it's as you said, if you do one at a time, there is less chance you're going to miss something or mess something up.
That's fine.
So I can't say do one at a time, because there are definitely times when I'm like, okay, change 3 things. It's fine, Yeah, we just work as we work.
Okay.
And the last thing that I also said is, if you're fairly confident your source code is running, again, you can be like, I can't be bothered to change the source code. I'm confident enough. Let me just make the test fail, then look at the console. Okay, my source code is returning 2. It's failing because I'm expecting 3, but I can see in the console it's working. I'm happy. So that's fine as well.
Yeah.
Okay, like you know
sense.
the reasons. You now apply them how you believe you need to apply them in your work. Okay, cool. Okay. All right. Great. So any other questions?
No, I think that's covered quite a lot, which is great. I guess for me, what I would feel my next steps would be, this is just like my personal viewpoint. I would like to go through a journey of learning Jest or the testing framework that I would use for my work really, really well, so that I know what tools are available to me and how to use them correctly. I think, and for anybody watching this who's in the same sort of stage as me, where you don't necessarily know a testing framework really well, like for me, Jest I'm fairly new to Jest. This has been great to understand how to go about testing all of your code. But I would go further with learning your testing framework really well, so that I know how to apply all the different tools available. Like, for example, the mocking system where you use the spy function, right? And things like that, and all the different ways to throw errors. And the fact that you mentioned how we can write describe first and put our tests in there. You know, all those little details that would make testing easier.
Okay, so yeah, I'd like to make a point in this as well, because I know that this is how you like to do things. You like to learn things well before jumping in. I would say if you're that kind of person, by all means, feel free to do that. For a lot of things, I do that as well, and I find it really valuable. But I would also say you don't have to learn your test framework perfectly for you to be productive with it right away. As long as you learn the basics, you can go on and do stuff. And as long as you understand the concepts of how to test that we've covered in this video, you can always go and search tomorrow, oh, I need a spy. How did I do spies again? Let me see. And then you spend 10 minutes, maybe 20 minutes looking at the tutorial for spies for your framework. So I think that's perfectly acceptable as well, you know? But yeah, obviously the more you know, the better. So feel free to have a good look at your test framework. But don't get too carried away either. Like if your test framework allows you to do weird, complicated things, don't do them. You want tests to be simple, how we've seen them
that
today.
Makes sense. Yeah, I guess what I meant wasn't for doing weird, complicated things. It was just more for being fluent and knowing what's going on with your testing framework. Yeah. You know, so like right now I could memorize this and apply it, but I don't fully know what's going on. If I study just a little bit, then I would know exactly how this is working. Yeah. And it would make me feel easier about applying it on my tests.
Yeah.
That's all.
Yeah, that's totally fine. Yeah.
Yeah. It's like people who use the class keyword in JavaScript, but don't really know how to create, how to instantiate objects using constructor functions. That kind of thing. You know? I feel like you should know, and then you can use class.
Fair enough.
And then you know what's actually going on. But that's just my way of thinking. You don't have to think the same way.
That's fine.
Yeah.
Well, I don't think more knowledge hurts. I think more knowledge can only help you. There are caveats to that, but yeah, I agree. Learning more is always good.
Okay. Very good, brother. Thank you. Do you have any other final words or anything else you wanted to go into?
Yeah, you know what? I think that's basically everything for this video. It's a complete introduction. And we've even covered some advanced concepts like testing I/O, mocking and things that you shouldn't do, and hopefully given a broad overview of testing and like how to actually make testing work for you, even as you become more experienced with these things, like with clean code and things. So yeah.
Yeah, well, thank you very much for the lesson. It's been great. And
my pleasure.
Yeah, I'm sure if anybody has any questions, you can post them down below, and Spiros is very good at answering. So, yeah.
Okay, so this was quite an informal, almost course on testing because we covered a lot of things and the video is quite long. But there are videos in the works to have a proper testing series in Programming DAC. So they're going to be a lot more to the point. They'll probably cover points that we've missed here because there's only so much we can remember when we're talking informally. So yeah, if you want to see more of these videos, do keep checking back. They are in the works and they're going to be quite thorough. And we're going to cover a lot more than unit testing as well. Also, if you're interested in a course about these things, we don't have one planned right now, but if there is enough demand, if people want something much more thorough, we could do a course on this as well. And that would have to be really thorough and really self-contained, and it would probably include a lot of practical examples and maybe even a project, testing a project as we're developing it or something like that. So if anyone wants something like that, or if you have any suggestions for what you would want, please feel free to leave a comment and, we might make it. Yeah, so that's basically it. So if you like this video, then please click like. And if you want to see more of these videos as they come out, if you want to be notified of them, then please subscribe. It really helps the channel when you do those things. And as always, if you have any questions, any suggestions, or even any counter arguments, then please leave a comment below. All right, thanks very much and see you on the next one.